What do you actually book?
Not too bad. How about you?
Good, very good.
Wonderful.
So when do you want me to start?
I'm going to just kick us off, Joe John, and then I'm going to turn it over to you and we will begin with
All right.
So good morning, everybody. I am coming to you from outside of Riverview, New Brunswick. And my name's Pamela. I'm going to be your host today. And you can put me on your screen. I'd prefer if you shoved me over to the side of your screen and enjoyed the beautiful PowerPoints that are about to come. But I'm going to just officially welcome you at the beginning of the day, knowing that some classes will be coming in throughout the day. And just welcome to the first ever virtual Learning from the Land series. Kind of ironic, but still we are on the land wherever we sit. So before we officially begin, I need to respectfully acknowledge 3 ancestral territories that we are uniting on this morning. In the West, we have people with us from Wolastoq territory, and to the south of us we have people from the Passamaquoddy territory, and of course our hosting territory of the Mi'kmaq people. So welcome everyone, and all of these territories, I have to say, are covered by the treaties of peace and friendship, and we at the Department of Education, where I'm working, Science East, Becky's here from Science East. We've got Agriculture and Natural Resources Canada with Bernie and Sheldon. JDI is represented in a few sessions in our wildlife presentation, and Ducks Unlimited is here, and we're all excited to be pulling this off virtually. And we are committed to honoring these treaties by ensuring that Indigenous perspectives are meaningfully included in environmental science and sustainability classes. So at this time, I need to welcome and say good morning to Joe John and Irene Senepas, elders from Elsipogtog. Welcome. Thank you so much for joining us and opening our day. And Joe John and Irene, I don't know if you can see this. Can you see this?
Yes.
I'm offering this virtually to you with a promise to gift it to you in person the minute we get up to Elsipogtog. So welcome.
Thank you very much.
You're welcome.
So you want me to start?
I absolutely would love that.
All right. My name is Joe John Senepas from Elsipogtog, and my spirit name is Musigisk, sky. And so I'm going to say your prayers, but first of all, moment of silence for our former chief, Albert Levi, passed away a couple of days ago. Okay. I'm going to say that in Mi'kmaq, and I'm going to say it in English. Ginny scum. I be sick doing it. I be sick doing it. When I do it, come lamon minnow. Chicolado senior one. At we check down where I be there, come lamon minnow. Kiss my down and my one maroke and Maularity. Maularity. Get me there in the morning, I get me there to make down the look there. Come on, I be sick doing it. All right. I say that in English. Oh, Great Spirit, Forgive us. Forgive us. Open up our hearts and the sickness that we have inside of our heart and pain. Let it go. Be able to work together, get together, pray together. Thank you very much. Alaliak. All right.
Thank you so much, Joe John. And I look forward to meeting you, as we all do, in person now that we are back to yellow.
All right.
So Joe gets here, yes, I'm sorry, man, here, this guy is.
All right. Okay.
I'm going to want it Monday morning now. That's right. I'm going to want this.
All right.
I know. Okay. I know. Thank you. Well, all yeah.
I tell you, we don't know the East, don't we?
Yeah.
Yeah. All right.
Okay.
Fantastic. Thank you so much, Ivan. And I have to introduce Ivan Augustine, who's graciously sort of spearheaded this whole event in Elsipogtog. So thank you, Ivan, for inviting Joe John and Irene too to start us off.
Yeah.
So here we go. Period 1 in Rexton, and teachers and students who are joining us. These are our host classes, and feel free if you have any questions to chime in through the chat. And we're going to try to watch the chat as Bernie Daigle from Natural Resources starts us off with his forestry session. Thanks, Bernie.
Okay, is my screen up?
Your screen is up and your sound is on.
Okay, because I wasn't sure, because I've got 2 screens here and I've only got the presentation on one. Well, first of all, thank you very much for the invitation. As Pam said, my name is Bernie Daigle, work with Natural Resources Canada, the Canadian Forest Service. I'm a forester. I studied forestry at UNB. And today, going to try to talk a little bit about how to identify trees and something about climate change and how climate change is going to affect our forest in the future, depending on how we deal with the challenges that we have there. So I'm going to get right into it. And okay, is anything happening there?
You are on your title screen.
Okay, because it's not moving.
Okay, I've given you permission.
There we go. The little mouse was in its corner. Okay, to start off, tree identification isn't easy. I remember trying to learn trees and looking at the woods, and everything seemed to be blending it into each other, and it's not an easy thing. The first step is to try to understand what the difference is between a softwood tree and a hardwood tree is. Softwood trees, we also call them conifers, and that's because they produce cones, and cones is where the seeds are. We also call them evergreen trees, and that's because most of the conifers hold on to their foliage during the winter, and they stay green. There is an exception, like in nature. Nature likes to throw some curves at us. There's a species called tamarack. Some people call it larch. Other people might call it hackmatack or juniper. All the same tree, but it loses its needles during the winter, and those trees are starting to change color now. In another couple of weeks, they'll be a bright yellow, and then they'll lose their needles like the hardwood trees. The hardwood trees, I'm sure you've noticed, a lot of the leaves have started to fall, and that happens every year. And that's a big difference. Another name for the hardwood are the deciduous trees. So deciduous, they lose their needles. I mentioned tamarack or larch, and that's one of the challenges in trying to identify trees. They have different names, different people call them different things. And it can be very confusing at times. I remember trying to learn trees, and people would say something else and says, I've never heard of that one. I wonder what that one looks like. But I already knew what it was. I just knew it by a different name. Another example of a tree that has several names is white spruce. Some people call it pasture spruce because it likes to come up in old fields. Or skunk spruce or cat spruce because of the strong smell that comes from the needles when you crush them. So it's important to know trees, and then when other people introduce a new name, then you might say, I know what that is. It's just that they're calling it something a little bit different. Another challenge is that you get a few, not very many, but I'm going to introduce a term called the species hybridize. It just means that the pollen from one tree from one species will fertilize a cone or a flower from another species, and that'll produce a tree in this case that has characteristics that are very similar to both. But these trees are usually fairly closely related anyway. But that's a challenge for even professionals at times. You start looking at something and say, well, I think it's a red spruce, and somebody will say, I think it's a black spruce, but it's because those trees tend to hybridize. Exotic or non-indigenous species is another challenge. And those are usually in municipalities or in parks. And we have a lot of trees that aren't from here. And you look at them and you say, well, it looks like this, but I'm not sure. The tools that I'm going to be talking about work well, but they only work well in the woods when we're away from these other types of trees. And finally, which is going to be the main part of the exercise here, using keys can help in identification. And that's what we're going to spend a little bit of time going over right now. So we're going to be talking about what's called a dichotomous key. And it's a tool that's used in plant or animal identification. It can be very general, encompassing a lot of different characteristics, or it could be very specific. There's keys that you identify a tree just by looking at a little piece of a twig. The key that we're going to be working with is much more general than that. So the way that the dichotomous key works, it'll ask you a series of questions, and each question is a choice between two characteristics of that tree that you're looking at. And the way that you identify the tree is by choosing the characteristic that best applies to it. So we're going to go through an example, and I'm hoping that all of you have copies of the keys, the dichotomous keys for the softwoods and the hard. Okay, good. You could pass those out. We're not going to need them right away, but it'll help follow and kind of get used to. We're going to be working with the softwood example first. So this is a key, and we're going to start just by, I'm going to lead you through an example of how you would use this key. So it says a twig and cone key for softwoods of the Acadian forest region. Acadian forest region is a name that came after the European settlers. You may know it as the Wabanaki region, because Wabanaki is what this whole region that encompass Nova Scotia, New Brunswick, Prince Edward Island, and parts of Maine. So that was that was known as Wabanaki, and the forest that is now called the Acadian forest was known as the Wabanaki forest. So I mentioned that a dichotomous key, a key is a choice between two characteristics. So I've highlighted there the first characteristics, and you see on the left it says number 1 and number 1. So we're always choosing between the same numbers. So the first one is the leaves are not needle-like, or the leaves are needle-like. So if you look at the images, the pictures on top, you can see that these are needle-like. So you would choose the second choice, and if you go to the far right, you see a number 3. So you look for the 2 lines that have number 3, and we see that we have, again, 2 choices. And the first choice is the needles are in bundles or groups, or we have single needles. Looking at the image again, you see that we have needles that are together. So we have groups. So you go to the far right, see what number that corresponds to, and it's number 4. So we have 2 more choices. This is the way that the key works. So we have choices again, 2 needles in each bundle, or more than 2 needles in each bundle. In this case, we have 2, so there's our choices. We have, it's either a red pine or a jack pine. And what you have to do now is see which of those 2 most closely matches the example that we have here. So if it's a red pine, the needles are straight. Yeah, these are fairly straight. 10 to 16 centimeters long. Well, these are quite a bit shorter than that. They'll break or snap when you bend them. We can't do that here. The cones are roundish. The cones are on the far right here. They're not really round, and 4 to 7 centimeters. And the cone scale's thicker at the tips, and we can't assess that based on what we have here. For jack pine, needles are yellow-green, 2 to 4 centimeters long. Well, that kind of fits. Divergent, that means that they're split apart, and you can see that the 2 needles kind of separate from that base. And twisted, we can't really see that here. Cones are about the same size. Serotinous, that means that there's pitch or sap or something that holds them together, that they don't open readily. And we can see that these cones are very much closed, and they're usually curved. So these guys are curved. So this is how the key works. So in this case, the answer would be, we're looking at a jack pine tree. So we use different characteristics. These are different types of leaves. We have what we call a compound leaf. That whole leaf here, that's a single leaf, and it has a whole bunch of leaflets attached to it. This piece here is called the leaf stalk or a petiole, and that's what attaches to the branch or the twig. A simple leaf means that there's just one leaf, and with a petiole or leaf stalk that attaches it to the twig. And there's another example here. And then we often call them needles, but they're also leaves. So just a different example of different types of leaves. We can use buds. This we'll see in the hardwood key when we start to try to identify hardwood species. And we have, the buds can be opposite one another, like here, there's a bud there, a bud there. There would be one here and one there. And out of the buds come the leaves. So if you see a line that says the leaves are opposite or the leaves are alternate, that corresponds to the position of the buds. So in this case, opposite, and in this case, these are alternate. When you look at the key with our native or indigenous tree species, there's only two groups of trees that have opposite buds, and those are the maples and the ashes. And if they're opposite and it's a compound leaf, then it has to be an ash. If it's a simple leaf, then it has to be a maple. So very quickly, even in winter, you can say, I might not know exactly what it is, but I know that it's either an ash or a maple, and it's none of the others. It can't be because of that characteristic. Bark, we've got 3 different types of bark here. Often that's all you need to identify a tree, different characteristics. We don't talk a whole lot about that in the key. And getting more specific, looking at seeds. Right here we have a red maple seed. These are white ash seed. That's a cone from the yellow birch. Balsam fir, acorns from a red oak, cone from a black spruce, and these are seed from a basswood tree. Okay, are you guys ready to do a little bit of work? And I'm not sure how this part is going to work because I sort of want you to do the work for me. If it works well, we can have a dialogue and someone can work through the key, because I'm going to put up the next slide is going to be some images of a tree species, and I want you to use the key to work through and identify it. Now, this is going to be a softwood, so you're going to have to use the softwood key, which is the same one that we use to go through and identify the jack pine. Okay?
All right.
But first, we have only 10 softwoods here that we find in the province or in the whole Wabanaki forest. Balsam fir, eastern hemlock or just hemlock, eastern white cedar, we know that as cedar. Tamarack, we've talked a little bit about that. 3 pines, jack pine, we've already identified, and there's also red and white pine, and 3 species of spruce. So I want you guys to see if you can tell me what this is by using the key. Some of you may already know what this is, but I would like to see the exercise going through the key. And if someone can just go through the steps. And working from home has its advantages and disadvantages. One of them is cats.
He's still bugging me. Just in case you were wondering.
Mine just came up and was threatening to disable my presentation here by walking over my keyboard.
The struggle is real.
So as
Students have the keys in front of them, and they should see the pictures on the screen. Micheline, is that working at your end?
Yes, they all have a sheet.
Perfect.
And we can see the pictures on the smart board.
Super.
Have a question?
This is that Envirothon workshop.
Is it all the same tree?
it's very much like an Envirothon workshop.
This is Bernie. He works for Canadian Forestry Service in Fredericton.
So,
Adam, you're not muted.
Oh.
guys,
But welcome, my dear.
Hi, Adam.
does it have needles or does it have leaves?
Do you have samples of the twigs or the branches? Because there's, and if you don't, I can work through it with my slides here.
Oh, guys, you gotta narrow it down. So pick number 1 is leaves, tropical legs, or leave middle leg. Was it leaves or leaves? Yes, thank you. It's needles, so I guess it's all called leaves, but they're needle-like. So go to where it says needle-like right here. Needle-like. So what are your next options? The bundles. Are the needles in bundles or groups? Are they single needles? Are they needles four-sided?
So this is a bundle? Yeah. So
They
Just-
needles in one, more than two needles? So are they single needles or are they two needles in each bundle? What are they? Needles in a bundle or groups? So you have two number threes. You have to pick out of the number threes, guys.
So for number one, you decide.
Yeah.
Yeah, so I got three.
So look, this is what you have to do. You have to narrow it down. Look here, look at the sheet. So you pick. So you say, leave not needle-like, leave needle-like. Okay, so we said leave needle-like. So now you need to go between number three and number three. Are they needles in bundles? Then I go to six.
Single, right?
Single.
Or is it a bundle?
It's in the bundle. No. Not there? Yeah. No. Wait, which one? That's a bundle. Oh.
Once you get to the that they're single needles,
Hi.
then
That and then the middle wash, please.
So now you have to pick between the
Seven.
There's single needles. So is it between the sevens now? Needles flattened or needles four-sided?
Thank you. Thank you. Have a great day.
You don't go to 5. Okay, if you pick out of all of these ones, you don't look at this. You go from your one. That's what we did. You go to your one, and then you feel like you're not needle like 5. You go to 3. So how did you get to 5? It doesn't tell you to go to 5. No, that's how you get. You don't. You go to what it tells you to go.
Do any of the kids, Bernie or
Yeah,
Michigan,
I
have trees in front of them? They don't have trees, or
oh, they don't. Okay. Well,
I think they're
maybe I'll,
going from the picture.
okay. I'll take over then. Okay. You should have all determined that the leaves are needle-like, and with the leaves needle-like, you go to 3. Are they singles or in bundles? They're singles, which brings you to number 7. And 7, you have a choice whether they will roll between the fingers, the single needles, whether they'll roll easily, or whether they're flat and they don't roll. In this case, the needles are flat and they don't roll. So if they're flat and they don't roll, it brings you to number 8, and you have the choice between eastern hemlock or balsam fir. So then you look at the 2 long definitions. So the needles are glossy, green above with 2 white bands and 3 darker bands below. So over here, you see 2 white bands, but there's only 1 dark band. They're attached to the twig by a short stalk. There's no petiole or leaf stalk there. And the cones are egg-shaped, about 12 to 20 millimeters long. That's for eastern hemlock. These cones are 8 centimeters or 80 millimeters long. So check out balsam fir. The needles are pretty much, they're very close to the hemlock, and they have 2 white lines and 1 dark line below, so that matches a lot better. If you had twigs and you would crush them, you'd get a very pleasant smell. And that's one of the good characteristics. The cones are cylindrical and erect, about 4 to 10 centimeters. These are 8, and they break apart when the seeds are mature. So the balsam fir cones are the only ones that stand up on the twig. All of the other cones tend to hang down. So in this case, we're looking at a balsam fir, and that is our provincial tree. And it's the tree that most people use at Christmas for their Christmas trees because of that nice smell and the nice shape and nice thick foliage. How about this one? This one is very similar to the balsam fir, so it would key out pretty much the same way. Leaves are needle-like again. So are they in bundles or groups, or are they single? Again, these are all single needles here. So we go to the single needles. We just looked at balsam fir, so this is probably hemlock, but let's see if it matches up. The needles are glossy green above. We don't have a picture of, this is the underneath, with two white bands and 3 darker bands below. So we've got 2 light bands and 1, 2, 3 below. They're attached to the twig by a short stalk. And that's what you see right here. Like, this is a very short stalk, and the balsam fir doesn't have that. And the cones are very different. Cones of balsam fir, of hemlock, are fairly small. They're 1 to 2 centimeters long, 12 to 20 millimeters. So very, very different. And if you look at the bark is very different. Here's the bark of the fir, and hemlock is a much older, a longer-lived tree, and it's very, very different. So that one was hemlock. Now, this one you're going to do on your own, okay? This is the softwood. How about this one?
Oh, it's my favorite.
Yeah, I see you've got a sample there. That's good.
Oh, good. All right. Good luck, everybody.
This might have been the easiest of the bunch, and maybe I should have started with it. But I want you guys to key this one out.
Do you have a prize for the first one to get it, Bernie?
I wish I did. Don't put me on the spot, then.
No. But students, you're welcome to come up to the chat and put your answer in if you think you've got it, or shout it out, because we can see you all on the screen and hear you. Oh, somebody's guessing it in Rachel's class, but I won't say it. Bernie, can you see the chat?
Okay.
Okay.
No, I can't.
Oh, okay. Well, she's half right. She's got the...
Okay.
Oh.
Nixon? Red pine. Red pine? Where is white pine? I know it's
red
white.
pine?
White,
Okay,
right?
how many needles?
I got red
Yeah, this one, the key to this one is that you have 5 needles per bundle, and it's the only tree that has that. The red pine has the long needles, but it only has 2 per bundle. So this is a white pine. It's got the longest cones, or the biggest cones of any of our trees. Very distinct, very on the landscape. You can see these trees from far away, and they're very easy to identify. But the easiest way, if you're up close, is to look at the number of needles. Okay, I want to get to some climate change stuff, but before doing that, I would like you to try one of the hardwoods, and then we'll jump over to climate change.
Super. You're doing great, Bernie. You have 20 minutes.
Okay. And okay, gotta get over here. So fine. So hardwoods are a little bit trickier. There's more of them. I've got 19 listed on the key. There's a few more that I didn't put in, and maybe I should have, but let's stick with these right now. We have 3 ashes, black, red, and white. Species called basswood, beech, 3 birch species, gray, white, and yellow, butternut, elm, ironwood, 3 maples, red, silver, and sugar, 2 oaks, bur oak and red oak, and then 3 poplars, balsam poplar, large-toothed aspen, and trembling aspen. So are you guys ready with your key and see what we can do here? How about this one? So the first line on the hardwood key is whether the leaves are opposite or not opposite. And remember what I said about the twigs and how the leaves come out on the twigs. So that'll give you a good clue as to where you should be, whether you should be on this top part with the maples and ashes or down below with all of the other ones. So does everybody agree that this is, the leaves are not opposite? Because otherwise you would have another bud right here that would make that the leaves would be opposite. So working from that, that brings you to which number? Can anybody shout that out?
Oh, if I, okay.
This one. The gray.
So which number should we be on if the leaves are not opposite? Number 8, right? So if you go to 8, you have, it's a compound leaf or it's a simple leaf. So if you look at this, is it a compound leaf or a simple leaf? I'd call that a simple leaf because there's only one blade and it will be attached to the stem or the twig by this leaf stalk or petiole. So if it's a simple leaf, then you go to number 9. And number 9, the 2 choices are the edge leaf, which is this part here. You see all those little teeth there? Whether it's single tooth or double tooth. So you look at the edge and you say, well, there's a tooth there, there's a tooth there, there's a tooth there. And if there are teeth in between those teeth, then it becomes double tooth. And I'll let you go from there. So if it's double tooth, where do you go and what's your answer?
So what do you think? Is it double tooth?
It's double tooth.
Yeah, it is double tooth.
Yeah. Okay, so where do you go from there? Or where do we go from there?
I was looking at this.
Are you looking at that one?
Yeah, 'cause this, and then you go to 10. No.
Yeah, I heard someone say that you go to 10. That's correct. So the next two choices are whether the leaf is triangular or it's not triangular. So you have to look at the shape. And do you consider that to be a triangular shape or not a triangular shape?
Triangle.
It is a triangle, yeah. So that tells you what this tree is. It's gray birch. And I think now I'm going to try to move to climate change and get some of that done. Again, if you want to use this key, use it in the woods, not to try to identify a tree in your backyard. It might work, but because it could be a planted tree, if your parents or somebody can say, you know, this is a native tree, you can try it out and it should work. And we're going to skip these guys. And we're going to talk about the impacts of climate change on the Wabanaki forest. This whole forest region here in Nova Scotia, New Brunswick, PEI, parts of Maine is kind of a transition zone between this big area here, which is the boreal forest, and another big forest down here, which is made up of more hardwood trees. These trees are better adapted to cold temperatures. These are better adapted to a bit warmer temperatures. And in here, we have trees that belong to that forest and that belong to this forest. So we're sort of at a transition zone. Start by talking about what climate change is. And I'm going to have a few graphs here. I know graphs can be a little bit hard on the head, but I think in this case, they're sort of important to show how things are happening and why they're happening. So climate change is a global change. It's not or regional change in climate patterns. And there's a difference between climate and weather. Climate occurs over large areas, over long periods of time. Weather is what you're going to have this afternoon or tomorrow morning. And it's largely attributed to increased levels of carbon dioxide in the atmosphere. And those are produced by burning or just using up of fossil fuels. The graph on the bottom shows the amount of carbon dioxide in the atmosphere. And this is in parts per million. So you're looking at between, let's say, 200 and 300. And this goes back to about 400,000 years. So a long period of time. And over that time, you see that the level of carbon dioxide has gone up and it's gone down. The big difference is what's happened over here. Since about, well, just before the 1950s, it's shot up. And that corresponds to a lot more burning of fossil fuels, a higher population in the world. So the amount of carbon dioxide has really shot up. What's interesting here too is that when the levels are low, it coincides to what we know as ice age. So back about 20,000 years ago over here, most of the region was covered by a sheet of ice about 2 kilometers thick. So very different conditions. So after that, as has happened in the past, temperature came up, but then it kept going up. And this is what is causing a lot of that climate change. So what does it mean? This is a graph showing the average global temperatures. It's not the temperatures that are here. It's the temperatures around the whole world from about 1880 to 2020. So about 140 years. And you can see that here it was fairly steady, and after that it started to increase. So we've gone up about a full degree in temperature over the last, I'd say, since about here. So close to the last 75 years or so. This is, I hesitated in putting this slide together, but it kind of fits with what I want to talk about. And there's a group from the United Nations, and they're called the International Panel on Climate Change. And they came up with different scenarios or stories of what could happen depending on where our carbon dioxide levels in the atmosphere are. And they came up with these RCP numbers. And RCP means representative concentration pathways. So they're basically scenarios. And this 2.6 assumes that we're going to get a control on the emissions of carbon, you know, within this century, and then it's going to start to go down. And if that happens, then we'll likely see an increase of about up to 3 degrees, and then it'll start to decline again. Now, research scientists use this information to, predict is the wrong word. It's a projection of what would happen. And it's based on a lot of factors. They look at different characteristics of trees, different moisture regimes, everything that they think is going to happen because of climate change, and they apply that to conditions or situations. And this guy here, Dr. Anthony Taylor, is a research scientist with Natural Resources Canada, the group that I work with. And I sent a small publication, Impacts of Climate Change on the Acadian Forest. And that kind of summarizes what Dr. Taylor went through. So if we get the situation under control, it's not going to be where we're still going to increase in temperature, but eventually it'll start to come down again, and the situation wouldn't be too bad. This 8.5 is if we don't do anything at all. We just let things go. We don't look at alternative energy sources. We don't respect the Paris Accord, which was a big international conference a few years ago, saying, you know, the world has got to do something about climate change. So we just let things go without taking any action at all. Now, action is being taken, so we'll likely fall in between here, because this is going to be hard to achieve as a globe, as the whole world is not likely to. You have some countries that'll participate really well, others that won't. This is the place that we don't want to be. Here is likely where we'll fall. But if we were to be here, then we would expect about a 7-degree increase. And that would put us about the same climate as, I think it's North Carolina, so quite far down in the States. What's going to happen to our tree species? This is the situation right now. If we go to this worst case or business as usual scenario, then we have some winners and we have some losers. And the winners are the species that are better adapted to the warmer conditions. So here we see red maple. We're about 11% right now. They're saying that we're going to have a whole lot more red maple because the conditions will be much better for red maple. Whereas our provincial tree over here, balsam fir, it's going to be at a disadvantage because it likes cool temperatures. So the amount of balsam fir will go from about 20% to about 10%. And you can see, like, this would be another boreal species that likes the cold, so it's going to decrease. And see which other ones. Yeah, white birch is another cold-loving species. So this is sort of the impact that it's going to have on the trees. I think I've only got a couple of minutes left here, if I'm right, Pam.
Yeah.
Okay, so I'm going to try to sum it up here. This is kind of the big changes that we can expect that will affect the forest. Precipitation, rain and snow. They're not expecting that we're going to have more of that. It's just the timing of it. So we're not going to have as many rainy days, but when we have them, it's going to pour. And we've seen some of that lately, just with downpours and flooding and stuff like that. Temperature likely will increase, which will mean more drought. Don't forget, we're still getting the precipitation, but it's warmer. That's going to dry it up. And a greater susceptibility to fire. And we saw this year that we've got more forest fires in this area here, but it's really a serious issue when you look at the West, especially California. The last few years, they've had a lot of problems, as in BC and Alberta. Forest composition, it'll favor the trees that are better adapted to the warmer and drier conditions. The productivity of the forest, it'll decrease, but it's mainly because of the time needed for the trees to adapt. You know, unless we do a lot of planting as this whole thing progresses, nature can't keep up with the rate of climate change. So some of our native species won't grow as well, and it'll take time for species that are coming into the area to replace these. And something that is happening right now is susceptibility to insects and diseases. As it warms, then certain insect pests or diseases can survive in the colder temperature. A good example of that we're seeing right now is an insect called the hemlock woolly adelgid in Nova Scotia. It was never there, and the last few years they're starting to have quite a bit of mortality from hemlock. And I think we'll skip that one and I'll stop it there. Is that pretty good timing?
That is amazing. You've given me enough time to ask the two classes an exit pass question. Miss Sullivan's class, can you hear me? Miss Maillet's class, can you?
Yes, we can hear you.
Okay, this one's for you. Miss Sullivan, I want to know if there's anyone in that class who can tell me the original name for the Acadian forest.
Rowan. Hold on,
Can you repeat the question?
I sure can. I would like to know if anyone in Miss Sullivan's class can tell us what the original name was for the Acadian forest we know today.
Go ask Rowan.
Who's Rowan? What a beautiful class. There's only 2 left in it. Where did they all go? It starts with W.
Starts with, yeah.
We don't know.
Isn't it just on the screen?
It is.
It's on the screen a few times.
Yes, we've lost the screen.
That's okay. Can you tell them?
It's Wabanaki.
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 All right, good job. Madame Maillet, are you there? Madame Maillet's class gets a question 2, an exit pass before we say farewell to period 1.
Hello?
Hello, Micheline. Hello, Nuzot. I want to know if you can tell me who's going to be the winner if our climate gets warmer and warmer and warmer, and the answer has to be a tree. Who's going to be the winning species if we continue?
Red maple.
Wow, good job. Awesome, Madame Maillet. So you get another one because I see you have a whole bunch of tips in front of you. Can you hold up, somebody there? Can you hold up the provincial tree or the balsam fir? It's a softwood, so I don't want to see any. Hold it up nice and high. Can you roll the tips in your fingers? Flat, that's a good sign. How do we know it's a balsam fir and not a hemlock or tamarack? Anybody? Maybe you don't have a hemlock there. I can't.
No, they might.
They might.
Try crushing the needles and smell. That's a good indication. You should get a pleasant smell if it's a balsam fir.
This is a balsam fir. Here, it smells like Christmas.
Smells like Christmas.
Super duper. Wonderful. Does anybody have any questions for the lovely Mr. Bernie?
That was awesome. Very interesting.
Well, thank you, Bernie. And class, you were incredibly well behaved. If I was sitting there in that class, I would be super impressed and I would even let you go early to your next class. I'm just kidding. Thank you so much.
Thank you.
I miss the classroom. I want to say though to everybody on the screen and still on audio that if I didn't get a key to you, if you would like the Dr. Taylor's package on climate change, or you would like Mr. Daigle's, Bernie's contact information, just shout out and I'm sure we can get that to you.
Absolutely.
Thank you very much.
You're welcome. Thank you, kids. Have a wonderful
Bye,
weekend.
everybody.
We're going to chime in to Ducks Unlimited here in a minute. Bernie, that was wonderful. Thank you so much.
Yeah, it's a little tricky with
Listen,
not being there, but
I think the pace was perfect, and I think it
Okay.
just goes to show that things have to just wind down compared to what they would in person, to pause and chat. And we've got a lot of feedback in the chat. Pat, I didn't get a key. Can you send me this? Can you send it? So lesson learned.
Good stuff. Yeah. No.
Wonderful.
Bernie, I got a question. You talked about hemlock. What's ground hemlock?
Ground hemlock is a shrub. The foliage looks a lot like hemlock, but the eastern hemlock is a big tree that'll live to 300-400 years. Ground hemlock is a shrub that might go to maybe a meter and a half at the most. What made ground hemlock sort of an important species is that it has taxanes that were used to treat cancer. So there was a lot of collecting of hemlock, of ground hemlock, and processing it to remove the taxanes and then using that as a cancer treatment. But both species are here in New Brunswick.
That's interesting. I don't know if it's how accurate it is, but like our elder that made a tribute there to Chief Albert Levi.
Yes.
several years ago, maybe 20 years ago, you know, there was he got ill with cancer, is my understanding, and then some people here, that's when they talked about ground hemlock, and he took some things from one of the people that knew about it here. I don't know if it's how accurate it is, but that was interesting when you mentioned ground hemlock and its use for some treatments.
Yeah, I believe that with a lot of our medicines, a lot of that stemmed from indigenous knowledge, that this was a plant that had many medicinal properties. So I think that if you had someone with indigenous medicine knowledge, ground hemlock would be one of the prominent species, as with the willows, which have other, and there's cedar, like a lot of the needles. When the first Europeans came, cedar was called arbor vitae because it was the tree of life, arbor tree vitae life, and they used it to cure scurvy with the early people that came. So there was a tremendous amount of indigenous knowledge in medicines because that's what the land provided.
Thanks, that's very interesting.
Isn't it though? And cedar is one of the sacred medicines, isn't it?
Yes.
Super.
Pam?
Yes, ma'am.
Can you hear me? Okay. So I just want to make sure that I get this right because I don't want to lose you.
Okay.
Oh, hello? Okay.
No, you're still here.
So do I leave this session open for the next one, or is there another link? Because I think my students have another session after.
Okay. The students that we just saw, are they
Yeah,
coming back?
Yes, they have wetlands after.
Yeah. So
Yes.
we're about to share the screen with the exact same link you got in your email.
Okay, cool. They are off to their break, so they'll be back at 10:35.
Perfect. Yes, ma'am.
So I won't be here. I'll be in another class with another session, but thank you so much.
Oh, thank you. This was great. It was wonderful, you know,
It
uncharted
was.
water, and we got through it. Super. And what
Yes.
a lovely class.
And everything worked. The sound worked. I was kind of scared that on my end something would go wrong, but everything went well, so we're all good.
Awesome.
Thank you.
So much, Micheline. Have a great
So-
sentiment.
Thanks.
Can I make one comment? It would be nice to hear the discussion in the classes as they're going on, because then you can contribute to that discussion at times.
I'll make a note of that.
Okay. Sometimes it might be too loud for you.
I think
No,
during
no.
No? Okay.
No, I think that's the sort of thing that we need in this type of interaction,
Okay.
especially when they're in workshop mode.
yes. Yeah. I'll
Okay.
ask teachers to unmute while the kids are working or interacting, and mute while the present, or just be quiet, as quiet as possible.
I'll just mute right now, so to let my kids back in, and then the teacher will unmute when
Okay.
he is told to, okay?
Super.
Have a good weekend, everybody.
You too, Micheline.
Yeah, you too, bye.
I should have asked her what teacher was coming in. Oh, she hears me. Yay. Is it
Mr. Ryu, Kevin Ryu.
Kevin? Perfect.
Kevin, yes. Okay, thank you.
Okay. So Bernie, I sent Sean the keys to distribute, and I was negligent to send it out to the other teachers just because I didn't think there were other classes, but I think I missed one.
Well, that's why I actually added a few slides with the key things to look for. So instead of just having one slide, my second slide was always the size of the cones, whether you could roll the needles, those little things, so
Yeah.
that if they
Jill.
didn't, like, actually they still needed the key. No, it's if they were struggling or if they didn't have the live samples, was my idea, but they did need the keys.
Yeah, that's something I think in the future have some kind of package as they register, whether it's a single teacher coming in for their own sake, like Adam's here, I don't think with his class, but regardless, if you register, here's the package, and at least they would have them as a resource.
Yeah, but definitely anything that they need, I will provide.
Super. Well, that went really well. And I believe Katie's on. Can everyone see her screen?
Yes.
Yes.
I'm gonna mute myself now.
Okay. Thanks so much, Bernie. Katie, did you get any of Bernie's session?
Yeah, no, I got most parts of it. That was great. Thanks, Bernie.
Yeah. So you can see there are 2 classrooms, and it looks like teachers are coming in and out of the same smartboard setup. I'm not sure, but we'll see if water kits show up here in one of these 2 classrooms.
And you know what? That's okay, because I'll just make mention to it in my presentation. Obviously, they don't have critters in front of them, but I have some pictures. And again, the interactive component will kind of be the Kahoot.
Yeah.
So
I'm going to do it on my phone.
Good. Yes. Can you see, when you see my screen right now, is it just the presentation itself? I just have it in presenter mode so I can see some of my notes. Does it look okay, or do you see my notes?
No, I just see your beautiful wetland title date. Yeah.
It's what you want to have.
Yeah. And Ivan, if you're still there, Katie, or pardon me, Caitlin was just admitted. You're going to start this off with a little Elsipogtog backgrounder.
Yes, just prompt me when it's time and when we're ready.
Perfect. I'll do that. And would you like to introduce Caitlin, or is that?
Caitlin Caller?
Yeah, she just came in.
Oh, okay, okay. Yeah, prompt me when the time comes.
Okay, will do. I think we've got a couple of minutes if you want to grab a coffee or a tea or take a break. If we're good to go, I am going to welcome Sherry into the, sorry, Sherry, I think I just cut you off at the chat. I'm going to turn the mic over to Ivan Augustine. He's right there in Elsipogtog, and he's going to give you a little background on how wetlands have sort of served a role or a service in Elsipogtog with the construction of the new school. And then we'll turn over the mic to our Ducks Unlimited guest, Katie, from, I guess she's coming to us from Nova Scotia. Is that right?
Yeah, that's right.
Yeah, Katie Scott. So Ivan.
Yes, thank you, Pam. My name is Ivan Augustine. I'm the Director of Education for Elsipogtog First Nation, a Mi'kmaq community. We're in the process of a construction of a new school, and the site that we chose, we didn't realize that there was forested wetlands in at the place where we wanted our school to be built. So one of the things we had to do was move our school forward and our track and field forward towards the street or the road that's right by it. So one of the things we had to do was we work with Ducks Unlimited is try to identify forested wetlands in the community and to use that as a compensation package to help in the cost for Ducks Unlimited. We did identify 3 areas in the community. We needed 5 hectares, I believe, and we identified about 6.1 hectares of forested wetlands that we're going to use as part of the compensation package. We're in the process of working with that with our funders, which is the federal government, the ISCOR, Indigenous Services Canada. Just having said that, I'd like to introduce Katie. We don't want to take too much of her time. Thank you.
Thanks, Ivan.
Thank you, Ivan.
Welcome.
That was a great introduction and segue into the wetlands presentation. So thank you everyone for joining me this morning. My partner Sam would be normally presenting this from Fredericton, and you'll see another coworker Alex who will be doing a presentation on Monday. So today I'm actually streaming to you from Sepeghenegity or Shubenacadie in Nova Scotia. So I'm across the line over here. But we're going to be talking about wetlands and why they're important. And at the end of this presentation, we do have a bit of a pop quiz as well. So I've set up a Kahoot trivia game that I'm hoping that we can play at the end of this. So just a little thing to keep in mind while you're listening to the presentation. All right. Pam, can you see the first slide there?
Yes, ma'am, you are good to go.
Perfect, thank you. So first of all, I am an education specialist with Ducks Unlimited Canada. And first I wanted to introduce our organization if you're not already familiar with us. Our mission is to conserve, restore, and manage wetlands and associated habitats that benefit not only waterfowl, but wildlife and people as well. And to reach this mission, we deliver on-the-ground habitat conservation projects. So that might include protecting wetlands where we can, restoring wetlands, or conserving them. It also includes research. So we have a research department that includes gathering research on wetland value and bird migration as well. And then, of course, where I come in is the education programs. So, of course, we need to make sure that people understand why wetlands are important. So, first of all, I brought this prop along with me here. I like to bring it around places. So this is my Earth ball here. Obviously, this is planet Earth. We are very fortunate to live on this planet, and we are one of the only planets that have all of this blue, which of course represents water. So some people can actually call this the blue planet because about 70% of its Earth's surface is actually water. So when we look at this planet, we say, oh, well, look at all of this blue that we have on our Earth's surface. We have plenty of water to go around, right? Well, unfortunately, that's not how it's seen or how it actually is. So even though it looks like we have a lot of water on planet Earth, when we break that down, of course, most of that water is actually salt water. So all of the water on planet Earth, if you take that, about 97% of it is salt water, which is great. However, that leaves only about 3% as fresh water. And of course, fresh water is what we as humans and certainly all of the other animals and plants need to survive. So when we look at that 3% and we break that down, only a small portion of that is actually available to us. So if you think about where we find water, this includes our rivers and our streams and our wetlands. And that's great because we can access water from those. However, a lot of our water is actually trapped in glaciers and icebergs, under the ground, and even in the air and clouds. So there's a portion of that we can't actually access. So although it may seem that we have a lot of water on planet Earth, we really do need to do our part to preserve it. And in fact, in Canada, if you take a look at our country, we can also be called the blue country. So in Canada, we are actually home to 25% of the world's wetlands. So that might not seem like a lot, but if you think about, again, thinking about our Earth ball, our globe here, 25% of the whole entire world's wetlands is within Canada. So we have, it's easy for us to take for granted that we have a lot of water here. But of course, we have a role to play globally as well to protect and conserve that. So now we're going to get into what is a wetland. And when I often ask younger grades in grade primary or kindergarten and one, they often say it's a land that is wet. And that's exactly right. It is a land that is wet. The scientific definition of a wetland is that land that is saturated with water long enough to promote wetland or aquatic processes as indicated by poorly drained soils, hydrophytic vegetation, and various kinds of biological activities which are adapted to a wet environment. So that's just a very long and lengthy way of saying a land that is wet. So often wetlands have clay-based soils. So of course, clay keeps water in on top of it rather than flowing through it. Hydrophytic vegetation just means plants that love water. So if you think about your cattails, lily pad, sweetgrass, and things like that. And then, so basically, we can break it down into two different categories. So we have wetlands that are mineral-based. So the soil in these wetlands are typically made of minerals, so broken down rocks. And then we also have organic wetlands. So those wetlands are typically composed of mostly organic materials such as peat, which is decomposed plants and other vegetation. So when we look at our types of wetlands, our first mineral type of wetland is classified as a shallow open water wetland. And this includes our seasonal wetlands, so our vernal pools that only have water during the springtime or periods of heavy rain. So there's a picture there of our shallow open water wetlands. Now, a lot of people are mostly familiar with marshes. They are certainly one of the more common or well-known wetlands. And typically you'll see these with lots of cattails along the edge. In the picture, you can see lots of lily pads. Now, of course, because we're very fortunate that we live along the Atlantic coastline, we also have salt marshes in New Brunswick as well. So these salt marshes are very, very important for protecting our coastline, which I'll get into in a little bit as well. And now then we also have swamps. Most people are familiar, or most students are familiar with these as Shrek's home, a swamp where Shrek lives, the ogre. So because of that and other reasons, swamps often get a bad reputation, but in fact, just like a lot of other wetlands, they do serve the same ecosystem services. So they do filter our water and provide us with clean drinking water. So there's our swamps. And then on the other side of the spectrum, we have our organic wetlands. So these include our fens, and not a lot of people have heard of fens before. They're very similar to a bog in that they have typically more acidic water, and because of that, our plants that live there are typically more adapted to that environment. So you might actually find carnivorous plants there, so plants that eat insects, so like our pitcher plants and our sundews. So they're really cool habitats. And the main difference between a fen and a bog is that fen typically has water flowing in and out of it, whereas a bog is more stagnant water. So it's usually fed by rainwater or groundwater exclusively. And there's our picture of our bog. So the bog, you actually don't see a lot of water in it, but it is certainly there. It's under a lot of that vegetation, right? And that's where the bogs get their name from. All right. So now that we know all the different types of wetlands, we're going to talk a little bit about why they're important in the first place. So why do we want to protect them? Why do we want to conserve them? So number one, wetlands provide a habitat for many species of wildlife. They are high in biodiversity. So biodiversity just means the number of species that live in this habitat. It is said that they're second highest in biodiversity, second only to rainforests. And you might be a bit surprised by that because, of course, when we envision a rainforest, we think of all of these birds flying around and mammals and things like that. Now, wetlands, we certainly do have a lot of birds and mammals that that live in wetlands, but certainly a lot of the biodiversity comes from the aquatic insects that are found under the water surface. And of course, they are the basis for the food chain. So wetlands provide a shelter to many species, a nursery, so a place to build nests, and a food source as well. Such as this little critter. So some of your classes may have received a wetland exploration kit, and that includes an identification sheet, as well as a dip net, a field guide, and a magnifying tab. So that's where these come in handy. So certainly we encourage you to go out and explore wetlands in your area, and you can do sampling for yourself. But this one, does anyone happen to know, and Pam, maybe you might be able to monitor the chat, does anyone want to take a guess at what this is, what this critter is? I'll give you a hint. You're very familiar with the adult version of it.
It spends more time in water, doesn't it?
That's right.
Who can we pick on this morning? Do they have keys in front of them or pictures in front of them? I'm not sure. It doesn't look like they have anything in front of them. Oh, sorry, I lied. So is Mr. Rayo's class there? Kevin, are you there?
I know what it is.
Hi. I'm in for Kevin.
Hi, substitute teacher. Anybody in your bubble have a clue what this little invertebrate is?
Ayla, take a breath. Somebody has an idea, but
it's a dragonfly.
Did I hear it right? Wow. And Miss Sullivan's class had a dragonfly larva.
Great, awesome. Yeah, that's right. And I gave you a little hint there. So it is indeed a dragonfly, so a dragonfly nymph. And so a lot of people don't realize that this is one of the many species that rely on both, of course, the water and land to complete its life cycle. So that's, again, another reason why wetlands are so important. So what the adult dragonfly does is that, of course, it deposits its eggs on some vegetation under the water in a wetland. And when those eggs hatch, it is the dragonfly nymph here that we see. And often a lot of people will think that they're spiders. Of course, you can count their legs and tell that they're not. They do crawl like one, though. So that is the dragonfly nymph. And then, of course, when it's ready to become an adult, and they can actually spend years underwater before becoming an adult, they come out on some vegetation, they shed their exoskeleton, dry their wings, and fly away. So just a little fun critter there. I do have one more critter. And this one here I'm going to give you because it's a bit trickier. This one here is called a caddisfly larva. So they build these homes, kind of like a cocoon, but it is actually a home. And they build these out of whatever material is available to them. So you can see this one here looks like it is built some of its home out of maybe some sticks. There's even a little tiny pebble in there too. And depending on the habitat, it might make it, so for instance, if it lives in a river, it would be mostly made out of pebbles. Versus a wetland, it's typically made out of more plant material. And another cool thing about these critters, they can actually tell us a lot about the water quality or the health of the water at a wetland. So if we're out critter dipping and we're doing a sample and we are finding mostly insects that you see on the right-hand side of the screen. So we have the rat-tailed maggot, the midge larva, maybe some leeches or snails. If you're only finding those critters, then that might be an indication that the water quality is fairly low and there's not enough oxygen there to support other insects. So if you look on the left-hand side of the screen, you'll see some species that are pollution indicators. So if we're finding these species, such as the mayfly nymph and the stonefly nymph, or even the caddisfly nymph, in the wetland, and that's a good indication that there's high oxygen levels and that it's a healthy wetland or water. So an important thing to know about this, though, is that these rat-tailed maggots, leeches, snails, etc., these poor quality indicator species can actually be found in any species. So if you're finding them, that doesn't mean that it's poor. It's mostly just the clean water indicators that serve as the pollution indicators. So the May findings and the stone findings. So wetlands are also important for many species that are at risk. A lot of people will often think when we think endangered species, we think exactly what my next slide is going to show you. So what I did was I searched endangered species, and this was the image that come up on Google Image. So there's a lot of, large mammals, right? These are kind of our poster animals for species that are at risk around the world. So of course, in the image, you can see there's some tigers and pandas, lions, polar bears, and that's all great. We certainly need to do our job or what we can to protect these species. However, there are a lot of other species that are in our own backyard that we should really consider, protecting their habitat on a local scale as well. So often a lot of people think of these as kind of the poster species. So in Canada, we actually have over 700 species that are at risk, unfortunately. And then I've broken it down here into this table that shows you the different classifications. So certainly extinct means that the species no longer exist. Extirpated means that it did once live in an area but no longer does, can still be found elsewhere. We have endangered, which is that the species is facing imminent extirpation or extinction. Excuse me. We also have threatened, which is likely to become endangered if nothing is done. And then special concern, which again, if nothing is done, then is likely to become threatened. So here are some examples that we have in New Brunswick and other parts. And these species all rely on wetlands or one way or another. So they might not live in a wetland, but they certainly rely on some of the values that wetlands provide. And some of these are listed either provincially or federally as well. So just a couple of examples, we have the Bathurst aster, which is a coastal or salt marsh plant, of course, in the northeastern region of New Brunswick. And this is listed as endangered. It is endemic to that area, so that means that it can't be found elsewhere, hence its name. We have the American eel, which is threatened nationally. And this species is really interesting as it spends most of its time in freshwater, but does migrate down to the Sargasso Sea through the ocean to spawn. And this species, of course, is very important to Indigenous communities as well. We have the little brown bat, or Myotis, and this is one of many bat species that are at risk. And of course, their main threat has been white nose syndrome, which is a fungal infection that they get that impacts their ability to detect seasons and causes them to come out of hibernation earlier than anticipated. And of course, they won't have a food source to survive. Then lastly, we have the wood turtle. And I know certainly Nova Scotia, it is actually 4 out of our 5 species are listed here in Nova Scotia, and they are listed nationally as well as threatened. So like I said, all of these species rely on wetlands in one way or another. Of course, wetlands provide a resting place for migratory birds. So of course, here we are at the end of October. A lot of our birds, like our hummingbirds, our warblers, most of them have already well made their migration down south, and some of them will be making it soon. Some of them migrate just to southern areas of the province, while some of them make much longer distances to South America. So we are on the Atlantic flyway, which is, you can see in blue on the screen. And so not only is it important for us to protect our wetlands here, but certainly these species require wetlands all along that flyway to make resting spots into their home and breeding grounds, or feeding grounds, I should say. Now, perhaps one of the most important reasons why wetlands are important is because they give us clean drinking water. So although I don't encourage anyone to go out and drink water straight from a wetland, what happens is, of course, when we have our water cycle, the rain comes down, hits the earth, and collects, unfortunately, pollution and chemicals that we have put on the earth that filters into our wetlands. Those chemicals and pollution sinks to the bottom, and specialized bacteria and plants in wetlands can help break that down, ultimately providing clean water to our wells and other areas. So you can think of them as a large filter on the ecosystem or on the landscape. Now, wetlands also help to prevent flooding, which of course, as we know, has become a serious issue, especially in New Brunswick. So you can think of wetlands also as a giant sponge on the landscape. So this here is a picture of a bog, and we've kind of magnified it so you can see these individual it's called sphagnum moss plant. And these plants are really great at absorbing water. So you can see on the right-hand side, there's one plant that has been filled with water. That's that bright green one. And then on the right, they dry up when there's not a lot of rain. So they can actually hold 25 times their volume in water, which is really cool. So they literally are like a sponge on the landscape. And of course, that's very important because when we have lots of rain, of course, in the springtime when our snow and ice is melting, we're very prone to flooding. So that those wetlands will absorb as much water as they can into the wetland rather than going into, say, your basement at home. So they also help to prevent flooding in another way as well. Like I mentioned earlier, we're very fortunate that we have a coastline that has a number of salt marsh ecosystems all along the coast. And these salt marshes are very important because they help to buffer wave action from our increased storms and storm surges. And of course, with climate change, this is becoming more and more of an issue in regards to sea level rise and the increase in number of hurricanes and other storms that we're experiencing. So kind of on that same topic, wetlands are also seen as carbon sinks. So they actually absorb a lot of the carbon material and it's trapped down into those wetlands. You can kind of see a horizontal picture here and a sample taken of that soil. So you can actually calculate the amount of carbon that is stored in these ecosystems. And salt marshes are proven to be one of the leaders in storing carbon. We often call that blue carbon just because it's of the connection with the ocean. So unfortunately, wetlands continue to be at risk. For a long time, wetlands weren't really seen for their value. Now, when they were, it was more important, I guess, to use the land for agricultural purposes. And of course, that still may be the case in some areas, but certainly, I think there's a partnership between agricultural and wetlands and promoting biodiversity on farmlands. You can kind of see here, there's some ATV damage to this wetland here, and certainly pollution is another reason why wetlands continue to be at risk. And certainly urban development as well. So we want to do what we can to protect these wetlands. So here is, if your class received this kit, this is the contents of the kit. So we encourage you guys to get out and explore them. You can put your field guides and Marsh Monster ID sheets to the test. Try to identify what you catch. And you can actually go out. We've even been critter dipping in the winter time before. You know, that life is still there, although there might be nestled in under the mud. But you can even go critter dipping at all times of the year. So now we're going to test your knowledge. So bear with us here because this is going to take some tech support, I believe. But teachers, if you have done Kahoot before, what I'm going to suggest is maybe 1 or 2 teacher or student representatives to log into Kahoot. Just because we do have a capacity on the number of people playing at once. So I'm just going to change my screen here. So what you have to do is you don't have to download anything. You just go on kahoot.it. So KAHOOT.it. And we're going to do a bit of a pop quiz here. So I'm going to
see the iPads. Great.
Team versus team. That's what you want. So in a minute, you should see a pin show up. Knew that was going to happen.
I'm playing my iPad.
Suspenseful music. Pam, can you see that okay?
I can see your presentation screen and the
okay.
directions on a slide. Yep, and your notes.
All right, let me share my other screen with you, my desktop. There we go.
There's the pin.
Yep, so there's the pin. So if you go on kahoot.it, and certainly even if you're not in the classroom, you can join in and participate with this as well. I encourage everyone to. Kahoot.it, and that's the game pin there. And so it'll ask you for the game pin. It'll also prompt you for a team name, so you can get clever with this. Maybe you want to be the Wild Wetlands or something like that. And then you can enter team members' names if you wish. You don't have to do that.
Yeah, we want to be the admirals.
The admirals?
Yeah.
Yeah. Max Aiken. Okay. School. Max Aiken. Is that your machine?
Yeah, it's too long.
The admiral. No, just put admiral. And then no, don't put admiral. We don't want that. We want admiral.
I think they like Kahoot.
It's usually a pretty big hit.
Put John.
How do I spell it?
A-R-I-L. And then S. Michael Jackson. Yeah. Michael Jackson. No. Michael
Okay.
Jackson.
Great.
Michael Jackson.
Michael Jackson. Pumpkin.
Let's be Michael Jackson.
All right, Elmo, Maddie. Oh, this is really cool. I can see everything. Sullivan.
Great. And if you can't get in, like I said, there is a max capacity, so I'm not sure if we've reached it or not, but if you can't get in, they'll play along.
Oh, there you go.
Someone said it.
Science East on the board. Where's Science East?
No, you're not. You're not muted, guys. Should we mute it? Can we mute it?
No, I'm too close.
I'll do it.
So do we have mostly everyone? I think so.
Looks good.
Okay.
Oh, Pam?
Yeah.
Okay, good, because my microphone wasn't working.
Okay, yeah, Michelin is in there. Are you on the game?
Yes, we're EPFI2.
Perfect.
All right, perfect. So I think we'll get started with the game. Like I said, I might have reached the capacity. I'm not sure. If you didn't get a chance to log in, it's okay. You can still play along. It just won't be calculated. So we're going to get started here. We have quite a few. That's great. Awesome. Okay. So what's going to happen is there'll be a question come up on my screen, the main screen that you're looking at. And then, of course, the device that you're using is going to serve as your controller. So it's going to show up as multiple choice. And certainly, obviously, you want to get the answer correct, but you also want to be quick with this as well. So you want you get more points for answering the question quicker. So you'll see the question come up, and you'll have, I think it's about 10 seconds before the answers actually will appear on your phone, and that just gives you guys some time as teams to discuss it, okay? All right, are we all ready? Okay, so let's get started.
Go.
And remember, if you are unmuted, you might want to consider muting yourself just in case you tell other teams the answer.
Good advice. Everybody's muted.
Okay, perfect. So we're going to do start. Are you smarter than a duck student? So what percentage of the world wetlands are located in Canada? All right, so you have 30 seconds to answer. Answers are coming in. We've got 18 answers locked in. 19. I think we have 23 people total, or 22. All right. So the answer to that was 25% of the world's wetlands are located in Canada. The majority of them were paying attention and got that question right. Good job. So 19, great. So here's our scoreboard so far. So Elmo number 2, you got the most points for that because you answered the question the quickest. All right. So we're going to go to question number 2. Which of the following is not classified as a type of wetland? Not classified. So the answers are swamp, saltwater marsh, freshwater marsh, and lake. Yay, great job. So lake is not classified as a type of wetland. So certainly it has the characteristics, and you will find wetlands around lakes and so on, but a lake is not classified as a wetland. Great job, guys.
Wow.
They were really paying attention, Pam. So you had a little bit of a shift in the scoreboard. Elmo 2 is still leading though.
Where is Elmo 2? I forgot.
I'm not sure. We'll have to ask. Why are wetlands important? They are cool places. They are home to thousands of species and many are endangered. They filter our water, giving us clean drinking water. Or lastly, all of the above. So I tricked some people on this question, and I suspect that it was probably people trying to get an answer in quickly. But the correct answer for this is all of the above. So they are certainly cool places. They are home to thousands of species, many that are endangered, and they filter our water, giving us clean drinking water. Great job, guys. I suspect that there might be some changes in the scoreboard. Let's see.
Wow.
Elmo 2 is still leading.
Kicking it. Who are you?
Who is Elmo 2? We have the Avrils, Pickles, Ahoy, and Chloe.
No, they're going to stay anonymous.
Yeah, exactly. They'll get bragging rights at the end of this. All right, let's go to the next question. Question number 4. Which of these wetland species is considered at risk in New Brunswick? The great blue heron, the eastern painted turtle, moose, or maritime ringlet? This one might be a bit of a tricky question. All right, we have all answers in. Oh,
wow.
Yeah. Good job. So yes, that's right. So the maritime ringlet is listed as at risk in Nova Scotia, and that's that butterfly that is endemic to salt marshes in New Brunswick. Great job. And I threw in the moose there because the moose actually is endangered here in Nova Scotia.
Oh, really?
Yeah, not the Cape Breton population. So that's the mainland moose that's endangered, not the Cape Breton population. Should distinguish that. Elmo too is still leading. Wow, they're proven to be a pretty tough team, but Pickles and Ahoy, you're not too far behind. All right, so question number 5. What is the wetland ecosystem that is highly acidic and has an accumulation of decomposed plants known as peat? Is it a bog, a swamp, a saltwater marsh, or a freshwater marsh? So highly acidic, and remember I said that highly acidic, there's lots of cool carnivorous plants that live in these wetlands too, like the pitcher plants and sundews.
I wish I could hear the talking.
I know.
All the hands going and the pointing. Oh, yeah.
Great job. That's
Maybe
right.
Elmo was one of those 2 that answered saltwater marsh. Let's see.
Oh. So yeah, most of you got it right. That's a bog. One of my favorites.
Oh, the Avrils are coming up.
Very close game. All right. All right. Let's go on to the next question here. Question number 6. What species of duck is this? So this wasn't from my presentation, but I thought I'd throw this one in here. So is this a mallard duck? Is it a green-headed duck? Is it a wood duck or a common eider?
Look at the hands. I love it.
All right.
Oh, jumping.
Oh my goodness. You know what? The question actually, oh my goodness. So the answer was, of course, mallard. So this is going to skew the results. Apparently the answer was inputted wrong. So my apologies.
No.
I knew we couldn't get away without there being a glitch with this.
There you go. So if you answered mallard, it's telling you it's wrong.
The good news is that this is only really going to impact one person's score, and that would be the one person who guessed green-headed duck. So they're going to have a little bit of advantage here. So my apologies for that one.
Look at that. Oh no!
Of course, they dethroned Elmo too. We really know who the winner, I think, with that one was because, yeah, that was my bad. I apologize for that.
Green-headed mallard. That's funny.
So in theory, the Avrils probably shouldn't have got those points. So my apologies, but Avrils, you are the leader scoreboard now. All right, number 7. What critter is this? So is it a leech? Is it a dragonfly nymph? Is it a caddisfly? Or is it a damselfly? Pam, if I know how competitive some of those teams were, I might have some people mad at me after that one.
Oh, well, while we're counting down, I'll ask you later.
Yeah. Oh, interesting. So there was a bit of a toss-up with this one. It is actually a caddisfly larva. So remember, that's the critter that I said builds those homes or those cocoon-like structures to protect them. All right. So some people had, actually the majority had thought damselfly nymph. Interesting. And then some with
that is.
Mm-hmm. All right.
Whoa.
Oh no, it's gonna be a tight one. All right, we have 2 questions left, 8 and number 9. how do wetlands mitigate the effects of climate change? Really read this question, okay? So they store carbon, they act as a sponge, lessening the effects of floods and droughts. Salt marshes protect our coast from sea level rise, or all of the above. So read this question through. How do wetlands mitigate the effects of climate change? All right, great job. So all of the above. So we did have some people say they store carbon, and certainly they do that, absolutely. Which is I guess mitigating the effects of climate change, but certainly they also protect us from our coast and act like a sponge, mitigating the effects of floods and sea level rise, which are also results of climate change. So great job for those who got that one. Now, Pam, we're going to go to our last question, which is question number 9.
Right.
So I think it's going to come down to this one. All right. Bonus.
Oh.
It wasn't in my presentation, but if you can, I'll give you a hint on this question. So what day is World Wetlands Day each year? It's not in the season that you would expect it to be in. So is it February 2nd, March 22nd, October 23rd, which is today, or August 7th? Oh, no one.
No
So
one. Oh, shoot.
I'm not surprised by that answer because you wouldn't expect it to be in the dead of winter, but it is. It actually is February 2nd. So World Wetlands Day also is the same day of Groundhog Day, which is another way to remember it. But World Wetlands Day actually celebrates the Ramsar Convention on wetland protection, and that's the date that it was signed. So that's why World Wetlands Day is actually February 2nd.
Huh.
Right. So let's see what that means for our. So in third place, we have pickles.
Silver medal, EF1. And gold goes to the Avrils. Yeah. They're going wild. Look at it.
Oh, great.
Hoot.
That's why they call it Kahoot, right?
Yes, sir.
Good job, teams. Now, I will apologize. I think certainly Avrils did get a bit of a leg up because they answered that one incorrectly that I had said was the green-headed duck, but it was the mallard. So my apologies on that, but I think everyone still had fun. And of course, you all just get the bragging rights anyway.
There you go.
All right, perfect, Pam. Well, I think that wraps it up for me, but certainly if anyone ever has any questions, they can reach out to myself or Sam.
Hey, can I ask a question?
Sure.
Yes, a quick question. Or just one thing about our school, the wetlands. We're putting like a path back there, kiosk for our kids to be studying about wetlands. When you mentioned that in Nova Scotia, a lot of white sand beaches, beautiful beaches, but every one of them has a like in the back a swamp or a bog of some kind. Why is that?
I think a lot of them have, it kind of just forms naturally because there's kind of like a, what's the word I'm looking for, a depression in the landscape before the coast. So that is one reason that it could be. But certainly we have lots of salt marshes along our coastline.
Yes, okay.
Yeah, so salt marshes are kind of our coastal wetland.
Okay, okay.
Mm-hmm.
Thank you.
Yeah, I hope that answered your question.
And you also mentioned the American eel that's endangered.
I can't remember the exact classification, but that's actually a national, it's on the national list, so Kasiwik, the Committee on the Status of Endangered Wildlife in Canada. So I don't think it's listed provincially in New Brunswick. It is listed provincially in Nova Scotia, and it's listed nationally as well.
but the American eel that is not generally not in wetlands.
That's right. They are a what they do is they migrate between freshwater habitat, which could include wetlands. And then they migrate to spawn in saltwater habitat. It's thought that they migrate to the Sargasso Sea to spawn.
Okay, thank you.
Yeah.
They actually, here in our Irish Town Nature Park, it used to be the water supply for the city of Moncton, and they've built an eel ladder on the dam to help these little guys get up into the fresh reservoir.
Yep, that's right.
Yeah.
Exactly.
They kind of creep me out a little bit, but
yeah, I've actually
so does the dragonfly. Yeah,
I've actually seen them, and they're kind of nocturnal in sense, which makes them even more eerie. But I'm from the south shore of Nova Scotia, and they would migrate over top into some of like the brackish ponds, and watching them migrate over top of the rocks from the ocean and into the ponds was just the eeriest thing. They're really cool.
And they're transparent.
Yeah, the young ones are.
The young ones, yeah. So Miss Maye's class, I see you there smiling at me. Do you have the kits in front of you? Michelin's class? Yeah? Okay, they're waving their nets. Can you put your net in the air if you are a student who can get to a wetland and do some collecting? Are you close to what? Perfect. So Miss Maye, I would expect you'll have some critters in your classroom maybe next week.
Yes, probably.
Super. I also want to put a shout out, Kate, that was fantastic. Wow, beautiful slides, and the Kahoot was a hit. If teachers would like exploration kit, could they reach out to me or straight to you for your contact?
Yeah, absolutely. Actually, Samantha Brewster would be the best contact. She's kind of my partner in New Brunswick, so she would be the one to contact.
Okay, super. So
yeah, absolutely.
Put that out. Email me if you don't remember that name or can't remember that name, and I would love to send you that info, or put it in the chat. But email's a little safer because I'm not the best at manning this chat. I'm doing pretty good, but I would love to see what's in the kit. If a student could come up to the mic or the video and show me. I see the dip nets. What else did they put in the kit? You all have invertebrate keys?
Yep. So they should all have the marsh monsters, actually.
Wow.
So it's a double-sided laminated resource that we have, and we take this on all of our field trips, and it really gives you a good breakdown. It has a size scale, it has some information, and then of course a picture of the critters. So, and another thing I should note too, this one is the one that we use. This is for freshwater wetlands, but we do also, this isn't in your kit, but if any teachers are interested, we do also have a salt marsh version of this as well, with salt marsh invertebrate species rather than freshwater.
Those are gorgeous keys.
Yeah.
They sort of, yeah, go ahead.
I was just going to say, so in their kits, they should all have, their dip net, and we have a little square magnifying tap so that they can see their critters up close. They should also have a field guide. So the field guide has a bunch of different species in it and lots of information on wetlands. There you go. There's a glass one. And then also a brochure on why wetlands are important. A side note, we do have most of these resources available in both French and English as well.
Super. So it's a little bit different layout than Bernie's dichotomous key. I'm assuming it's pictures only and not, does it have 2 antennae, does it have 1, 3, but it could be available in the same sort of format that the tree key was in the last session, which is kind of fun. But I love the colored laminated version. You can drop it in the wetland and use it over and over because it won't be ruined. Wow, that is a gift. Thank you so much. I don't see any questions in the chat. And I don't see any hands in the air. Does anybody have any questions for Kate? Or we do have another wetland friend on here, Caitlin Collar. If anybody has a question before we go, feel free to chime it in. And Adam, I got your request for a kit. Lisa Hawkins class. I see a young man right in the front row. Can you hear me? Yep. All right. There's a question for you. Oops. Can you tell me, or Katie, what percentage of fresh water is actually available for drinking? It's not in ice and it's not salt. Here it comes up to the mic.
25%.
25%. If we could be so lucky, eh, Kate?
Unfortunately not.
It's a little less, a whole lot less, but thank you for participating there, Miss Hawkins class. Now you that just gave the answer, I want you to look to your left and send your buddy up to the mic with the right answer. There he is. How much is available? And it's less than the purple shirt.
4.
Ooh, what do you think, Kate?
You're getting much closer.
Getting closer. So blue shirt with the pink cast on your left hand, you look behind you and send somebody up with an answer a little less than yours. Available fresh water.
5%.
5%. You went a little higher. Sorry. We're going to get you to send the Harvard hoodie up with an answer that's less than, let's help them out, Katie, less than 3%.
2.5.
Ooh, Harvard is off, but closer. How about Levi? Come on up with the red hoodie, Levi. How much water do we have available to us? I see Rachel Sullivan has chatted the right answer. I want to hear it from Mr. Levi in the red sweatshirt.
1.
1% is still too much availability of drinking water and fresh water. Levi, send up a friend in the class to give us the right answer. Unbelievable small amount available to us.
0.0. Is it 0.5?
It is.
Let's go.
Good job. Wonderful. And Miss Sullivan, thank you for your chat answer. Great job. And thank you for participating, Miss Hawkins class. So I will say, I think it's just about time to dismiss this class and invite our soils, our dirt man, to the screen. So thank you, class. If you have a break, now's the time to take it, and we'll see the next session start here in about 5 minutes. Actually, in about now.
Thank you. Bye.
Thank you. Salute.
Thank you.
Bye.
What a great class. And Kate, are you still there?
Yeah.
That was wonderful. Thank you so much.
No problem. Yeah, I think the Google went great. I knew there had to be at least one glitch that would happen, and that was totally on me.
That's hilarious.
Where you have a lot of deciduous trees, and then you have more of a mixed wood. So there's something going on underneath there that's giving us an indication that we're going to find something different from this location to this location. And again, you can see on this facing this slope here, the way it's facing, we're getting more deciduous trees again. Anyway, so those some examples of some forest landscape images that can kind of direct your mind into thinking, okay, there are differences, there are patterns, and these patterns can help explain or are clues to what we're going to find underneath. So now we'll just switch over to some agriculture pictures, just a couple of them, and you guys can you see any patterns that are forming here or that are showing up? So you can see this is a grain field, so that's actually wheat in New Brunswick. And you can see that the wheat has there's different heights here in the wheat. You can see that there's kind of this line that runs down between the field here. There's another here. There's one right in front of us. You can see that the wheat color actually is different. So this area is more mature than this area. There's still some green left in the plants here. Oh, I went too far. And you can actually see that the farmer didn't farm any of this ridge top up here. So these are patterns that are going to give us some indications of what we're going to find. So these areas in between these fields, the reason why they're probably showing up as a different color and a different height is because they've probably been in production, or the farmer has not worked those areas. So you get less compaction in the soil. So then the plant is able to grow, the roots are able to go down deeper into the soil. You can see that the elevation or the slope of this portion here is probably too steep for the farmer's equipment. So then they're not going to go and farm that area if there's chances of erosion and those things happening. So these are all these patterns that are kind of giving us indications of what we're going to find. And then this last picture I'll show you is a potato farm in Grand Falls, New Brunswick. And can anybody tell me any patterns that you see in the landscape?
It has a lot of swirls and looks like I thought it was a wall at first, kind of like a brick wall. But now that I'm looking at it, I can see the potato farm.
Yep, that's great. Yeah, so these swirls that you're seeing, those are actually, so this is an aerial image, so it's kind of like a bird's eye view looking down on the landscape. So what these are actually called is they're called terraces. And so this field here has a slope. It's pretty steep. Same with over here. It's steep going down this way. So what the farmer has done is he's blocked up his slope or his fields so that he can minimize the amount of erosion that's going to happen. So by creating these kind of separate subdivisions of his field that follow the contour, it's called following the contour, he's actually minimizing the amount of soil that's going to erode across the slope, down the slope. So then by doing this, he's minimizing the erosion and keeping the soil on his farm instead of in the waterway. He's also installed some waterways you can see in between the fields. So farmers will do this to help direct the water flow. So if a grower has a steep slope, they can create these terraces, but they also put in these waterways so that the water that's moving across the soil will actually find this waterway and travel down. So we can actually direct the flow of the water to the stream, minimize the erosion on the farm. There's another pattern that shows up here as well. You can see that these areas are darker in the field. Does anybody have an idea of why they would be darker? You can see one kind of vein there and another spot over here is kind of darker than the surrounding area. Can anybody have an idea of why that would be? Go ahead, lifeguard.
Sun on some.
Oh, or yeah, go ahead, American Eagle.
Was it harvested or plowed or something?
No, good try.
Didn't mute it.
Anybody else?
Hello. Come on, guys. Anyone?
The sun ratio. Sun. Ish.
So the sun. So that's a good guess. That's but what it actually is that that's all it is. It's just water in the soil. So these areas that are darker are water. Areas that are lighter colored. So these are the reasons why that he's or she is the farmer is actually putting in these terraces is because they are trying to minimize the amount of water, trying to minimize these dark areas. They're creating these terraces to minimize the amount of water and soil that moves off their fields. Same with down here. And here you can see there's actually plants that have been planted, crops that have been planted in here. And you can see that there are different, these sections are really brown in color, whereas these sections are really green in color. So that's giving us an indication that the soil here, there's a reason why it's a lighter color, a brown color. The plants aren't doing that great there in that location, versus here, the plants are doing really good. Greenness is a indication of plant health. So if you see areas that have very little green, then there's probably a soil indication of a soil problem that we need to look at. Awesome, great job, guys. So back to the presentation. So what exactly is soil? So we just looked at, what are some ways we can look at patterns in the environment or in the landscape, and that give us indications about soil. But what exactly is soil? So soil is the top layer of the Earth's surface. It's composed of minerals, organic matter, living organisms, water, and air. And these components all work together to support life. And they're continuously changing, so they're dynamic. They're not static, so that if something is added to the system has to change in order to accept that new addition. So then why do we study soil? So why is it so important to study them? Because everything is directly or indirectly linked back to soil. So soil provides nutrient cycling. If I get my mouse going here, nutrient cycling, they provide habitat, flood regulation. Katie just talked kind of about that as well with the wetlands and soil textures. They're foundation for all the things that we build. They provide us food, fiber, and fuel, sorry. They sequester carbon, or they supply carbon. They link carbon into the soil. They purify water. They regulate climate. And then everything is, just gonna move. Sorry, guys. So then our actions affect the soil resource. So everything we do affects the soil resource. That's why we need to understand it to make sure we use it sustainably. So for future generations, my kids, we need to make sure that that soil is healthy, has good quality for the uses that they need and what the uses that the environment needs. So here's an example of why I study soil. These are some projects that I'm involved with. So here's an example of a potato field in New Brunswick. You can see that the potato crop has been planted. There's what happens is that there's very little soil coverage, so the soil is not covered. When the soil is not covered, it's not anchored properly, so there's not a lot of roots holding the soil in place. And then you get a rainstorm come through, and a lot of this soil is productive soil that's used for farming or used for other, provides all those functions that we looked at in that last diagram. A lot of that soil leaves the soil surface. So here you can see these, fine sediments, these silts and clays that hold a lot of nutrients. Those are washed off of the landscape. I'll get my mouse going here. Yeah, so these all end up in the waterways and in, sedimentation, provided sedimentation in fish habitat, affects everything down the line. So not only the soil particles are washed away, but everything that's within the soil as well gets washed away. So then what's left on the farm or on the field is less productive soil. So, and here's another example. So a farmer came in, they had a crop planted, they came in and harvested the crop, and before they could seed anything in to hold the soil in place, there was a massive rainstorm, and you get this gully erosion down through the field, and these sediments are being washed away from the farmer's field and into the water system. So the reason why I decided to study soil and get into soil is because we want to be able to minimize these effects on the environment. So what can we do to help keep the soil in place, keep it productive, and provide those functions for organisms and habitat and food provision and all those functions that we looked at. So now we know what soil is, we know why we study it, but what exactly does it look like? So there's two main broad classes of soil. There's forest soils, so soils that are found in the forest, and then there's agricultural soils, or soils that are found in agriculture. There's also organic soil. I won't talk about that. I know Katie had just mentioned about that, the organic soil in bogs and marshes and those things. So if we look at a forest soil, how it looks, you can see this is what we're looking at above ground. So you can see the trees and the fallen trees, the plants that are present on the surface of on the forest floor, it's called. You can see cones and needles, those types of things. But then if we dig down into the soil, we actually can see these really, yep, exactly. We can actually see all these soil horizons. So if we did, some people think that, you know, soil is one color all the way through, and what they don't actually realize is that there's all these different layers that go down through the soil, and each one of these layers is an indication of what is in the soil. So for a forest soil, you can see that there can be up to 5 different horizons. There can be a forest floor horizon. There can be a forest floor horizon. And this is just the organic material that has fallen from the forest above. So things like leaves and twigs and plant species that have died off, any of the mosses, those types of things, organisms. And the forest floor horizon is made up of organic material. There's no mineral soil. So the mineral soil is sand, silt, and clay. There's no mineral soil, it's just forest floor, just organic matter. And then once we get past the forest floor horizon, we see this A horizon. So this is the first mineral horizon, which means that it has sand, silt, and clay and the organic matter. So these organisms that I was talking about earlier, yep, litter, twigs, leaves, yep. So this A horizon, this A horizon is the first mineral horizon, and when you had these organisms will actually break down all this forest floor, they'll break down this organic matter, turn it into a thing called humus, and this humus is fully decomposed organic material, and the organisms will actually mix it in with the mineral soil. You create this kind of like brown or black A horizon. So the brown and black color means that it's enriched, or it has a lot of organic matter in it. After that horizon, you can see this white band, and it's really cool to see in the field because it's really bright and brilliant. And what that means is that as rain falls down through the soil profile, you get this leaching. It's called a leaching layer, an eluviated layer, and you get all the water is actually drawing out all of the nutrients from that horizon. It leaves it this white color. And then after that horizon, we fall into the B horizon. So all the nutrients that have been pulled or leached out of this A horizon then get deposited in this B horizon. And this B horizon is usually a really rich red color. And then we just keep moving down through the horizon. So there could be a transition here from a B to a C horizon. So the B horizon is, you know, could be a little less red or a little less enriched than the previous horizon, but you know, it's still enriched with nutrients. And then the C horizon is pretty much the bedrock. It's the bedrock that is starting to decompose or starting to break down. And what you'll notice is that the plants that grow above here, so the forests that grow above here, they reach their roots down to this B horizon. The B horizon is enriched with nutrients and minerals, and the plants know that. So they actually bring their roots down and will actually find this horizon so they can get the nutrients they need. And as you move down in the soil horizon, the amount of organic matter decreases, but the nutrient concentrations can increase. So then if we look at an agricultural soil, so here's a barley field that was planted. And then if we dug into that soil, we can actually see, there are colors that are present here as well. They're different, or they could be a little different from the forest soil because it's been disturbed, because the tractor will come in and they'll plow the field, turn that soil over, plow down all the organic material from the previous crop. So if we could just step through these horizons as well, you can see here that, so here's the crop on the top. Then you have this AP horizon. So the AP horizon is just, the P stands for plow. So what you'll find is that a lot of plows are 15 centimeters or so deep. So what it does, it goes down to 15 centimeters or so, and it actually takes all this soil and will turn it over, mix it up. And what this does is it allows the microorganisms in the soil to help break down the material so that it can be ready for next year's crop. So you get this AP horizon. After the AP horizon, you can still have this eluviated white layer. You can see it's not really white, but there's classifications that go along with all this. So, and then you get this B horizon again. So this enrichment of nutrients in this horizon, and then the C horizon again. Any questions about the horizons? Awesome. All right, so now that we've learned what soil was, how to identify it, what does it look like in the field, in an agricultural field and a forest field, but how do we know if it has good quality or not, or if the soil is healthy? So let's define what soil quality is. So soil quality is the capacity of a soil to function within an ecosystem or a land use to provide productivity, maintain environmental quality, and promote plant and animal health. So this is a kind of a big statement, and all it's really saying is that each soil has a purpose, whether it's our purpose or the environment's purpose, and we need to be able to measure, we need to be able to find indicators or measurements that we can then identify, is it meeting the criteria it needs, or is it providing the function it needs? So if a soil is if the land use for a certain soil is agricultural land use, it's a farm, then we need to be able to measure certain properties within the soil to see if it's actually providing that, that function. Or if it's a soil is it's for wildlife refuge or like habitat for organisms, we need to be able to measure those indicators. How can we what can we measure that can give a good indication of, is this soil providing good habitat? So that's soil quality. Now, how do we measure soil quality? And this is kind of what I was getting at from my previous statement, is that, so there are soil quality indicators, and then there's soil properties that we can actually measure that can give us indications of the soil quality. So there's three main broad classes of soil quality indicators. It's physical, get my mouse here, physical, chemical, and biological. So the physical properties, these indicators, are ones that we can actually go to the field, take a soil sample, measure. It's things that help. It gives you an indication of how easy is it to pass water and air through the soil, and that kind of links back to how easy can a plant get its roots into the soil. So things we can measure are things like soil texture or soil bulk density. It can give us an indication. So if an area is really compact and we go to plant a crop on there, you're not going to, the seedlings are going to have a really hard time getting through the soil. So therefore, soil quality would be lower in a soil with a higher bulk density than a lower bulk density. And then if we look at the next indicators like chemical, so these are actually things we can actually measure. We can take a soil sample from the field, we can actually measure all of the nutrients that are in the soil, things like sulfur and
nitrogen
and potassium and phosphorus, all those things that are necessities for plant growth. So we can actually take a soil sample and measure those, and then if the soil quality is high, you'd expect to have many of these nutrients available. If it's low, you'd expect that the quantity of these chemicals would be low. And then if we look at biological, these are things where we can actually measure the amount of organisms in the soil. So organisms break down the organic matter that enrich the soil with nutrients. So we can actually go out and we can take soil samples and actually count the number of different species or the number of different groups of organisms. And we can also take measurements of soil organic matter. It's the food that it's the food for these organisms. So we can get an idea of what is the soil quality based on how much organic matter is present, and then the biological activity or the amount of organisms that we find. So then for physical, we can look at soil texture. For chemical, we can look at the different elements that are found in there, or the different nutrients that are found in there. And biological, we can look at soil organic matter, or soil color is a really good indication of the organic matter that's present. So let's talk about some of these soil properties. We'll just touch on 3 of them. So the first one is soil texture. It's under that soil physical indicator. So soil texture refers to the sand, silt, and clay that's found in a given soil. So when I was talking about earlier about the mineral soil, it's the sand, silt, and clay. So you can see the different size classes here. So here's sand, silt, and clay is extremely small down at the bottom. So the soil texture influences the amount of water the soil can hold, the rate of movement, so how fast water and air can move through the soil, and then how fertile the soil is. The silts and the clays tend to hold on to nutrients, and sand tends to open the soil more. You can see the diameter classes. And then these different combinations, so the sand, silt, and clay occur together. They could or could not occur together, but different combinations of sand, silt, and clay, different percentages, give rise to these soil texture classes. So here are the texture classes that we have in Canada. They run from sand all the way down to clay. So you can think of, this is would be like beach, on the beach where the water passes through really quickly. The clay, you would have all these small particles put together. You would have very little water going through it. It would be really compact, whereas the sand, lots of water would run through quickly. So the texture classes run from coarse, which are sand, to fine, which are clay. And then loam is a relatively even mixture of sand, silt, and clay. And you can see there's many different types of texture classes as you go down through: loamy sand, sandy loam, and all these come with percentages of sand, silt, and clay. So then the next property we can talk about is soil color. So soil color would fall more on those biological indicators. So soil color provides valuable clues to the nature of the soil, conditions, and fertility. And it's produced by the minerals that are present in the soil. So things that come from the bedrock that it originated from, the amount of organic matter that's in there, and the soil drainage. So here's a picture of Prince Edward Island, a potato field in Prince Edward Island, and the soil is extremely red in color. Does anybody know why it's so red? What is it high in that allows it to be red?
Potassium, someone said.
Try. Try again.
Anybody have a periodic table in their classroom? Go ahead, lifeguard.
Iron. Say it louder, Angel.
Iron.
Wait.
Iron. Yeah, great job. That's fantastic. Yeah, exactly. So if you think of it's iron oxide. So if you think of it, if you leave your car outdoors too long and without it painted, you end up getting iron oxide or rust on your car. It's the same with the soil. The soil in PEI is high in iron oxide, and which provides it that red color, but it's also really fertile as well. And that's why it's so great for agricultural production. And here's a picture of two different soil types here. So the one on the left is high in organic matter. You can see how dark it is in color. So this is an indicator of high organic material, high organic matter, which is then related back to it's usually a more productive soil than one that has lower organic matter. There's more organisms present. They're breaking down the soil. They're allowing these nutrients to become available that are in the soil. And the one on the right is more of a less organic matter. It's probably lower in a soil profile than this soil. So that's why it's farmers will actually add compost to soil to increase the organic matter so they can increase the soil quality. So and then soil color is described by a Munsell color chart, and I sent some out to the school in terms of hue, value, and chroma. So this is more on the soil science side of it. So if I'm going to the field, I'm going to classify a soil, I'm going to classify each of the horizons based on their texture and based on their color. And this will give me indications of how quickly or how slowly air and water will move through it, how much organic material is present, and how much minerals are present, or what types of minerals can be present. So an example of soil color would be 10YR56. You'll see that in a second when we go to our Munsell books. And then the last soil property that I'll just talk about today is soil drainage. So soil drainage kind of links everything back together. And it's defined by the length of time it takes water to be removed from the soil in relation to the supply. So if you think of that soil profile, it rains on the soil, and soil starts to move, the water starts to move down through the soil profile. Well, if you have really fine textured materials like clays and silts that are in the soil profile, you're going to get little water running through that soil profile, which means that you're going to have more surface erosion. More water is going to run off the surface. Whereas if you have a sandy soil, the water is going to run through it really quickly. So here's an example of 3 different soil profiles that can be found in New Brunswick. This first one, you can see, this is a forest soil, and how you can identify that is looking at the litter layer on the surface or this forest floor horizon. You can see that this black horizon, you see that's your AE, or the AH, sorry, the humus layer, that high organic material. You can see the white layer that I was talking about in places, and then this really kind of rich red color as well. And then as you move down the soil profile, you see where the roots are located. They're in this B horizon again. And this would be classified as a well-drained soil. There's 6 different classes: rapidly well, moderately well, imperfect, poor, very poor. And what we usually find is that anything above moderately well and above tend to have really bright colors, tend to be usually the soil horizons are really prominent, it's called, where you can actually see the different horizons from each other, just like that first picture. The second picture you can see is an imperfectly drained. So once you move below this class 4, imperfect, poor, very poor, the colors tend to be less present, and everything kind of looks a little washed out in terms of color. And then if you look at this horizon, you can see that this top layer is pretty dark in color. This is an indication that it's a agricultural soil. So this is your plow layer, and then you get that transition down into the soil pit. And you can see that there's actually water present in the soil pit. So that gives you an indication that it has imperfect drainage or poor drainage. And as well as you can see, there's not really a big differentiation, or there's no change in color as you move down the soil profile. There's a little bit of color difference, but nothing really stands out at you. And then if this last poorly drained soil, you can see it's a forest soil again with the organic layer on the top. You can see the white horizon again, but then once you get past that white horizon, everything is almost the same color. You can see some differences. This looks a little drier, this looks wetter. So that's where we get that poor drainage. Water is actually seeping into the soil pit. Yeah, so you'd expect that This would have a more coarse textured, sandier, loamier texture. This would have a finer texture, or probably like a silt loam, silt texture, and same with this. This would have a finer texture again. So lots of water passed through, less and less again. And see if I can go down. Oh, okay. So now I've got like 15 minutes maybe?
Yeah, about 12.
All right, it's great. So what we're gonna actually do is we're actually gonna do an exercise together to determine the texture of the soil based on one of the soil samples that I'd sent. So if you have it, and I have a soil key, a texture key right in front of me on the screen, we'll leave it on the screen, and hopefully you guys can see me go through this exercise with you. So if you grab the Stony Brook soil, so it's like a red colored soil. I don't know if you guys can see that well. So it's a red soil. If you just, maybe a couple of volunteers want to grab a handful of soil, a handful of dry soil in their hands. You're going to get dirty, so that's okay.
Lots of volunteers, I see.
That's great.
Yeah, super. It's wonderful that you got those out in the mail to the kids. Okay, I see Michelin's got hers. Rachel didn't receive anything. She's at a different school.
That's okay. So I'll go through it with you guys just so you can see. I'm going to mess up my desk. Like
okay, I think Krista's class, are those soil samples you have in front of you? Yes, perfect. And Megan too. All right.
So you're going to grab a handful of soil. So if you just start at the top of the key of the texture test, it says place approximately 25 grams of soil in your palm. So just fill up your palm with soil, and then we're going to add water to it and make a putty. We're going to see if it makes a putty. So I have a squirt bottle here. We're going to add some water to it. It's going to be messy, but then that's okay. So we're going to add water to it, and what you're going to try to do is you're going to try to make a putty.
And Sheldon, your hands are below your screen, just so you perfect.
See if I can tip my screen a little more.
Perfect.
I almost grabbed my coffee to add water to it. All right. All right, so it's starting to form a putty. Awesome. All right, so I've formed the putty. I'm just going to wipe some of this off my hands. If you were able to make putty, maybe just hold it up in your hands so I can know that people have finished step one.
I have a putty in the back with a black shirt. Rachel's class has a putty, no?
So can everybody see that? Yeah.
Yeah, that's perfect. How is Miss Gallagher's class doing? If you want to come up to your screen, feel free, students, if you have a volunteer who's following.
There we go.
Yeah, come on up and show what you've got to Sheldon.
No,
Who needs more water?
I'll show Sheldon.
I'll go show you. They got 2 more water. Just like your putty light.
Weird.
You need more water on that?
Yep.
Thank you, Ms. Betts. Thank you, Ms. Gallagher's class.
Alrighty.
Great, so just hold on to the putty once you've made it. Great job, guys. So I'm just gonna move on to step number 2. And it says, so once we've made the putty, it says, does the soil, let's see if I can get my screen to, where is my mouse?
I see your screen perfectly. Yep.
So here, does the soil remain in a ball when squeezed? Yes, it does. We just did that. So then we move down in the key and it says, oh my. Place the soil between your thumb and your forefinger. And what we're going to try to do is make a ribbon. So you want to take the soil in your hand and you want to, using your pointer finger and your thumb, you're going to push the soil. Can everybody see this? You're going to push the soil over your finger and make a ribbon. And what will happen is that it'll actually crack off under its own weight. So you can see it, mine cracked right there under its own weight. Where is it? And we want to hold on to that ribbon that we just created. So I'll do that again. So push it between your thumb and your forefinger. Here, try to get a good picture. So you can see the ribbon that's being created?
Yes, beautiful.
Mine just cracked off right there.
So if that were a lot of sand, Sheldon, you wouldn't get any ribbon at all.
Exactly, yep. And if it was high in clay, you get a really long ribbon. So did anybody make a ribbon?
Feel free to show off your ribbons if you have. Here comes one. Whoa, Sheldon, his is better than yours.
You should be a soil scientist.
Look at that. Good
Awesome.
job.
Fantastic.
Wow.
Perfect. Yep, perfect. That's great, guys.
Good. Miss Gallagher, you've got some agricultural stars in your class. Miss Maya, have you got any ribbons out there? Yep, good.
Awesome. All right, so the next step, it says, where's my mouse again? Does the soil form a ribbon? Does it form a ribbon?
Yep.
I'm gonna assume everybody is yelling yes. Does it make a weak ribbon? So is it less than 2 centimeters long? Is it 2 to 5 centimeters long? Or is it more than 5 centimeters long? And I need you guys maybe to unmute to tell me how long your ribbon is. So mine, I did have a ruler here somewhere. So mine is 5. Can anybody raise, who can raise their hands who had more than 5 centimeters? Anybody?
Yeah,
one.
got red arm going up.
All right, 2. Any 2 to 5? How many people got 2 to 5? So it looks like more than 5 is the answer. Is that what we're coming?
I would say.
All right. So if we go back to our key, it says, does the soil make a strong ribbon greater than 5 centimeters long before breaking? And we say yes. Some mouses. So then what we need to do is we need to take a piece of that little ribbon that we had. Sorry. Take a little piece of that ribbon that we had, and we're going to put it in the palm of our hand, and then we're going to excessively wet it. So you can see I'm just going to add some water to it, and you're going to make,
Perfect.
you're going to make a mud. Just make mud on your hand.
And don't share your soil. Kidding, kidding.
So what you should end up with is mud on the palm of your hand. So does anybody have the mud on their hand?
Oh, here's one.
Full of mud.
Sweet.
So then the next question asks, does the soil, can't see it, oh, there it is. Does the soil feel very gritty? Does it feel smooth? very smooth, or is it both smooth and gritty? What do you think? Gritty or smooth, or both?
Mine's kind of gritty. I have both of it on my hands, and it feels gritty.
Agreed. Yeah, I think it's gritty as well for me.
Yeah, yeah.
Oh, mine's gritty. No, smooth, actually. I lied.
I made a ball.
Majority of it is gritty. So then, if it's gritty, what is the texture class?
Oh, yours is like really, I'm scared. It's kind of smooth.
We're here.
You've been struck by smooth criminal.
Yeah.
Here, if it feels very gritty, then what is our texture class?
Mine's more watery.
Horse.
Horse.
Sandy
I
clay.
I don't think that's a
Sandy clay, is that what you think?
There you go. So then that would be.
loam.
So then in the field, you would say, you know, the field texture is sandy clay, and then we would take a soil sample back to the lab, and we would do an actual analysis for texture, where we use a hydrometer and some graduated cylinders, and then we would actually time.
Admiral Page to the office, please. Admiral.
Yep, awesome, good job, guys. Yeah, no, and then we would actually be able to measure the percent of sand, silt, and clay. So then we would be able to know exactly what the texture class is. And it's kind of a really kind of nice trick to be able to see how close your field test is to the actual soil sample. So with the kits that I provided 2 other soil samples. We won't go through them, we don't really have the time, but you feel free to, I can send you the texture key, and you guys can work through them on another time. We don't really have time for color as well, but you guys can keep the texture, the Munsell books for the time being, and you can go through them. So the way the Munsell books are set up, so here's a Munsell book. So the way they're set up is that soil color can be found on the pages. So what you would do is you would actually take your soil sample. See if I can do this. Take your soil sample and you would put it underneath, and there's a hole by each color. Let's see if I can do it.
And match it up.
And you would match it up. So then you can go through the book, you can find the color that matches your soil color, and then in the book you would have, there's hue is on the top of the page. So here you have 10R, for example, and it goes all the way to yellow. So the book, if I pick a right page, there's some organic horizons, colors for some organic horizons. Here's more yellowish colors. So you have hue 2.5Y, for example. Value is along the inside, so it'd be 6. And then the bottom, you would have, oh my God, it's so hard to do this backwards. You would have chroma on the bottom. So it would be like, you know, a 2.5 Y 6/2, something like that. And that gives us an indication of what we can actually find in the soil when we actually do the soil tests.
Yes, sweet.
Yeah.
Fantastic.
So then the last slide that I have is, you know, a picture of, I think it's the Restigouche River. And so now you can then start to connect these pieces of, you know, here's the landscape, look at the patterns of the landscape, and what can you start to put together in your head about, you know, why these plant species are located in these areas. You know, why are there more coniferous trees down by the water and more hardwoods as you move up the slope, and as you get to the top of the slope, there's more hardwoods, south-facing slopes versus north-facing slopes. Where do you think the water will be located based on the trees that are present? Yeah. And that's all I have. So if there's any questions, I'd love to have a couple, as long as they're not too hard. And yeah, and thank you so much for having me today.
Hey, that was wonderful.
Thank you very much. Thank you so much.
If we were in the field with you all today, Sheldon would be standing inside of a soil pit and you'd be looking at soil horizons face to face. But perhaps next month we'll get to do that. But Sheldon, thank you. That was a great review for me as well.
Just wait, they'll notice it.
Yeah, I loved soils. The more I appreciate what it takes to grow our food and support our houses and our highways and our wildlife, the more I really, really appreciate the science of soil.
Yeah.
Because it's really undervalued, don't you think?
Yeah, completely. I think that, you know, people just take it for granted, right? Until you start to see, you know, effects happen downriver or effects happen on a farm or in a landscape, and then it's like, oh wow, we really need to manage. It's about managing the resource we have to ensure that it performs the functions that we need it to perform. Not just we as people, but as you know, a landscape, you know, ecological services need.
Yeah, absolutely.
I'll just unshare my screen.
Was fantastic. I think.
Thank you.
Thank you.
Thanks. I still have a question.
You have a question? Go right ahead, sir.
How do you take this stuff off? Do you just wash it off, or like?
Yes, Andrew, you'll wash it in the bathroom. It's just dirt. Wash it. You'll be fine.
Oh,
Wash your
it's
hands.
so much more than dirt. Actually, it's not much more right now. So again, I think Sheldon would be more than obliged to share his contact information if anybody would like to learn more or ask a question they might not have asked or forgotten to ask on the chat here. The Munsell books you can keep and just we'll reach out for those. He'll want those back obviously at some point. I think
I'll get them when I need them, type of thing. I'll reach out.
Perfect. And the soil's theirs.
Yeah, completely.
And
I forgot to mention, sorry for interrupting, Pam. I forgot to mention that 2 of the soils that I sent you, the one that we actually work with is found in your area. It's Stony Brook. It's a Stony Brook soil, as well as there's a riverbank there as well, and that's actually found in your area as well.
Cool.
So
those
the samples that I have were actually collected just outside of your guys' area, and then we take them back to the lab. We sieve them and, you know, do our calculations and our analysis on them, and then we store them because we know that they're kind of like a standard soil.
Neat. And I will end by saying we have a provincial bird, we have a provincial tree, and we have a provincial soil. So there, if somebody wants to chat and tell me that they know what it is, I will, you know, kudos to you. But I'm not going to divulge that. I'll let Sheldon do it maybe in his next session. A provincial soil. So thanks again, Sheldon. Class, I'm assuming that this is your lunch time. And I'm going to leave the chat, I'm going to leave the screens open. Go take your break, or we will resume with Kelly Honeyman at 1:55. If you care to join us for that, come back on, or I think you could probably sign out and sign back in. The link will still be there. So have a nice lunch, everybody, and I will see you at 1:50.
Good night. Thank you. Thank you.
Thank you.
So
right
thank
on.
you anyway. Yeah.
Okay.
Well, thank you everybody for allowing me to present here today, and I'm happy to do this. It's always great to spread the joys of nature and birding especially. So welcome to Birding by Ear, and I realize that a lot of you aren't birders yet. Probably a lot of you have birds and bird feeders in your backyards and know the occasional one. We're going to take it a little step further and try to get you to actually identify birds by the sounds or the calls that they make. So this is typically how people start out birding. You know, they've got they're in their backyard, as I mentioned before. They're looking at bird feeders, taking a walk through the park, and they're seeing birds. You take a little step further, and you might buy yourself a pair of binoculars or borrow a set from somebody. And if you're really interested in it, you probably will invest, a few bucks, $20 or $30 into one of these field guides. And these are 3 of the most popular ones for our part of North America: Sibley's, Peterson's, and National Geographic. But I can almost guarantee you that it as exciting as this is, it's not a sport that's for the for reflection, because at least not when you're in the field. What happens typically is birds are, pardon the pun, but they're flighty creatures, and you really have to be quick in your identification sometimes. And one of the little secrets I have, and it's really not much of a secret, but I usually stick a big Post-it note just inside one of my field guides and inside my Peterson field guide. And when I see a bird, I'll do a very, very, very quick sketch of what that bird looks like. And because they're here now, but any second they could be flying away, and chances are you won't be able to identify it with your field guide that quickly. So a real quick sketch with some key features identified, and obviously the color of it, maybe there's some bands or stripes on the wings or on the tail. The shape of the beak, is the beak long and thin like a sandpiper, for example, or is it a more robust beak, a thicker beak that's used for cracking nuts and so on? So making a note of what the beak looks like, and just general patterns or colors is important. Where you're finding it. Are you in a hardwood stand? Are you in a marsh? Are you on a sand dune? I think a habitat you'll probably remember fairly easily. Any particular habits that it has? Are you finding that the bird spends a lot of time walking on the ground? There are birds that do prefer to walk around rather than flying. Is the bird at the very tops of the trees and flitting or flying from treetop to treetop, or is it coming down into the middle of the woods? Is it bobbing its head? All of these things, make just quick notes of that. And if it's making a particular call or a song, we're going to get into this a little more heavily here in just a bit. Just try to describe that call or song on the page as well. And all those things will help you when you have a moment to open up your field guide and identify the bird that you've witnessed. You may get lucky; they may stick around for a long period, but just in case, a quick sketch is good. It doesn't have to be as nice as this one on the screen there, that's for sure. So birding by ear it's an important thing to learn when you get into the natural sciences, when you're getting into things like field biology and ecology, because chances are, if you're looking at a bird in the forest, there are probably a half dozen to a dozen birds that you're not seeing. They're very well camouflaged. That's just over hundreds of thousands of years of evolution. That's what they've done best. So you probably won't see many birds, but chances are you will hear them. And so birding by ear is an important skill to learn. The picture that we've got up on the screen now is myself and another birder, Richard Black here, doing some bird census or some bird monitoring in and around Fundy National Park. We've done hundreds. I think we've got over 600 hours of birdsong recordings from southern New Brunswick, from northern New Brunswick and Maine, and we're using these recorders that you can see on your left-hand side, your right-hand side. We're using those recorders to be our eyes when we're out in the woods. We can place those out. We can place out a whole bunch of them. And with that, we can find out just exactly what birds are using that stand. because birds, their songs and their calls are just like our signatures. They're all different for different species. And by listening to the songs and the calls, a computer algorithm takes the sound files and can actually separate out what birds are there. Now, sometimes you get regional dialects that throws a computer off. So sometimes it doesn't work ideally. Sometimes you have to have a birder that's actually sitting down and listening to these sound files. But as you can imagine, 600 or 700 hours of bird songs is a lot for one person to go through. So we tend to let the computer try to do its best first, and then go from there after, I guess. So what is a song and a call? A song is simply a series of specialized notes strung together and it's used to attract either a mate or to announce or defend a territory. Okay, simple as that. And songs are typically song-like. It's not just one or two notes. It's a series of notes. Whereas a call is a little bit sharper, a little bit less complex, and it's typically just one or two notes, maybe strung together. And calls are typically used for alarm signals, announcing that predators are in the area. Or if it's a case of a foraging flock, some birds tend to stick together in groups, especially in the wintertime, as in foraging flocks. Then they will use these calls to keep the flock together as they're traveling through the forest or up above. Okay, so calls are less complex, as it says here, less complex series of notes, typically with just one or two, maybe three notes, whereas a song is a little more song-like, I guess is the best way to put it. So let's try to open up one of these files. I can guarantee you that all of the birds that are going to show up on this slide. You're going to know them certainly by their some of them by their songs and their calls, and some of them certainly by their that's an easy one. Right? I think everybody's got that. That was an easy one. Yeah. So is that a song or a call?
You can use the chat, class, or blurt it out to your mic. What do you think?
It's a call. There you go. You guys are awake. Yeah,
you know
everybody
what
said you'd be.
Yes.
Well, yes. I kind of took it for granted, but do you know the species?
Canada geese. Canada geese.
There's no fooling you. Okay, Canada geese, exactly. Okay, let's try the next one. And unfortunately, I've got my, there, I'm gonna move pictures around here. Let's try this one. This one's tougher. I don't know if you've got your mic or your sound turned up on your computers, but you probably should if you don't, because we're going to be dealing with a little bit of sound here today. That's a tough one. Try it again. You'll know it when you see it. I hope, anyway.
A robin.
A robin.
A robin? Let's try.
Oh, it's a chicken. Oh, it's a chickadee.
Black-capped
Chickadee.
Provincial bird. Exactly. Now you're saying to yourself, that doesn't sound like the chickadees that I hear. Now, is that a call or is it a song?
No, it's a song.
Song.
You think so? He's doing it.
It's a call.
It's a call. I don't know who got that, but you're right. It is a call. We're going to play the song in a bit here. And you'll say to yourself, yeah, of course. I got to move people's faces again here, and then we'll try this one. This one's a tough one. That's a tough one. But I bet you when you hear the other vocalization for this thing, you'll know what it is. Can anybody guess what that is right now? Its throat gives you a hint to its name.
An ostrich.
No, white-throated sparrow. White-throated sparrow. That's a tough one. So let's go on. Let's do the next page here. So you've got the calls and the songs. You've differentiated between those fairly well by now. Let's try this page. Let's try this one. This one.
That's a
Heard that before, haven't you? I bet you have. It's the black chickadee again. Black-cap chickadee. Okay. Oh, and then we've got some playing too. Ahead of ourselves. So that is the song of a black-cap chickadee. So that cheeseburger is cap chickadee. Okay, so let's try this one. Just heard it just a moment ago. Oh, so somebody yelled out. So somebody very astutely yelled out cheeseburger when we were talking about this. Cheeseburger it's kind of a mnemonic, isn't it? It's a way for our minds to memorize or to put a sound to a name. Okay, so if you think of black-cap chickadees and the song being cheeseburger, and if you've got this little image in your brain, then you'll probably not forget that. Okay, so let's go on to the next one. Black-cap chickadee. Let's go on to this one. Anybody ever heard that before?
Robin! That's a robin!
Oh, you're trying on that robin. I know you are. Okay, we'll bring it.
It's a chicken.
That's the same. It's the same. What do we call it? I can't remember. What do we call it? There you go. The white-throated sparrow. Very good. Okay. So if you look at it, if you see the mnemonic, it says, "Oh, sweet Canada, Canada, Canada." Okay. Now, if you were down in the States, they'd say, "Oh, sweet Peabody, Peabody, Peabody." But in Canada, that's what we call it. Okay. That's the white-throated. There's the mnemonic for the white-throated sparrow. Okay. So we're going to go back to the chickadee. And do you remember what the call, why do they use calls? Do you remember way back in a few slides back?
For mating.
Calls, not songs, calls.
For a predator. If they're
Predators, exactly. Alarm calls, right? Alarm calls or keeping a flock of birds together. So chickadees have got a fairly elaborate series of calls that they use to warn other birds about predators being in the area. And they've got two fairly distinct ways of doing that. If chickadee sees a predator flying overhead, and that predator is obviously going to be either a hawk or an owl, it will let out just a very discreet.
Well, wouldn't that look like predator over there?
That's it. That's what it'll do. Just let out one discrete little tss. Okay, so that's for a bird that's flying overhead, a predator that's flying overhead. Okay, but if the predator is stationary, if the predator, let's say it's a bird that lands on a branch, or let's say it's a cat at the base of a tree or even us, even if they see us, if it's not flying overhead, they let out a distinctly different call. And I'm just going to play that for you.
Chiquitas.
So this guy is saying his name right now, isn't he? Chickadee-dee-dee, chickadee-dee-dee-dee. And every one of those D's that you hear in the chickadee-dee-dee, for every D that you hear, it means that predator is less of a threat. If a chickadee goes chickadee, then just puts one D in it, and this is what they found in the study down in the States, one D means that there's a serious predator on the ground or stationary somewhere nearby. Okay.
Wow.
If there's multiple D, then it's a predator, but it's not really as much of a threat. So it's a way of ranking the fear factor. It's like the doomsday clock or DEFCON 5 kind of thing. If we're talking about 5 or 6 DDDs in the call, then it's not much of a threat to them, but they still want to let their buddies know. So, and if you listen to the call here, let's look at count the number of DDDs. Like 4 or 5 on that one, isn't it? So I would suggest that we're talking about probably a human. It's probably the guy that's supporting the chickadee. That's probably the predator that bird is reacting to. And that's why you're getting 4 or 5 just something to think about. Try that out yourself when you're out in the woods.
Hairy woodpecker.
Hairy woodpecker. Okay. So we've got about 4 or 5 different types of woodpeckers in the province of New Brunswick. We've got 2 that are very similar in their looks. Downy woodpecker and a hairy woodpecker. The big difference between these 2 is a hairy woodpecker's, we'll go to inches, but no, I'm gonna say it. A hairy woodpecker is about 22 centimeters long from tail to the top of their head. A downy woodpecker, a little bit smaller. They're about 6 inches, about 15 centimeters. So there's a little bit of a size difference between the 2. Otherwise, they're essentially the same. You can see a male and a female here on the image, and you can see the male with the red on the back of the head. Okay. Now I'm going to play the call, or I'm going to play the vocalization here, and you tell me what you think is happening, whether it's a call or a song. Okay, so you get a lot of stuff going on there, don't you? It's the first part of the sound file where he's going down. That's actually the predator call. Okay, so what he's doing is he's announcing to all the other woodpeckers in the area and most of the other birds that are listening too, that there's a predator in the area. Now, the end part isn't really a vocalization at all, is it? Did you guys get that last little end part? Let's see if we can bring it up here again. Nope. Back. Previous. Almost skipped myself, skipped ahead here. Oh, did it again. All right. Did you hear you heard the tapping, right? And that doesn't surprise you. Everybody knows that woodpeckers tap on things. But they do that for very particular reasons. That isn't used for a predator call. That's actually used to as a courtship call, or to tell to establish a territory. And I can't tell you the number of times I get calls in the spring of the year from people, and they say, Kelly, I've got a woodpecker that is beating his head against the stop sign in my road. Or I get calls, people saying, Kelly, I've got a woodpecker that's beating his head against my siding on my house. What do I do? And it's not that that they've got some sort of brain worm going on or there's some issues there. They've figured out that sound off a metal sign or off the siding on your house travels a lot further. And because of that, they can establish a bigger territory. They can draw in a mate from a further distance because they're making the sound is amplified by doing that tap 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 tap. So that's why you hear the woodpecker tapping like that. Okay. Pam was talking a couple days ago. We're mentioning about adaptation and grade 8s. By the time you've got to grade 8, you should have learned a little bit about adaptation. So I'll try to point out a few things here. But here's a classic one. This is the bottom image is a side cut, or a sort of sliced section of a pileated woodpecker skull. And if you look at where the orbit is, the eyeball, you can see underneath that there's a bit of a curl there. Bring my cursor around, you can see the curl. This is actually the tongue, okay? And if you are a bird that earns its living by pecking into trees and getting insects from deep inside that tree into your stomach, you want to have a fairly long tongue to be able to capture those insects. And a short tongue like we've got in our bodies isn't going to cut it because it doesn't stretch out far enough. But pileated woodpeckers have evolved over thousands of years to have these longer tongues that are able to stretch out twice the length of their skull. And so that helps them to grab onto the insects that are inside the tree and eggs and so on. Another important feature of the pileated woodpecker is, can you guys, and I don't know I don't know the resolution on your screen, but can you see at the tip of the tongue, can you see some little barbs there?
Yeah.
Yeah.
Yeah, perfect, good. I was hoping that was gonna hold up on your image there. So again, they've got a little barbed tongue. That coupled with a really sticky saliva makes for a pretty good way of spearing or sticking insect eggs to the tongue, because you got to remember, they can't see, they're just sort of feeling around, and they're trying to grab onto as much as they can before those insects start running away up or down the tree, right? So that's what that's all about, just a little bit of adaptation of their skull to let them be able to forage even more successfully. So we've been using these mnemonics, right? Cheeseburger for the black-capped chickadee, for example, right? We've been using mnemonics to try to, in our head, figure out what the song the bird is saying. But there are other ways you can do it electronically. You can take that vocal energy and turn it into electrical energy and create these little sonograms. That's what you see on the screen here. I don't know how many people in your grades have Android devices, but if you want to start and do some birding by ear, you can grab this bird net. I don't often flog particular pieces of software or apps, but this bird net app is pretty darn cool. Because what you do is you just point your phone at the bird, whatever the birds or wherever the bird sound's coming from. It records it, it sends it off to a big database down in the States, and within a few seconds you get a response saying what that bird is. Now, most of the time it's pretty good at guessing what the bird is. Now you got to remember, a black-capped chickadee in BC doesn't sound quite the same as a black-capped chickadee does in the Maritimes. There's differences in dialects, okay? It's somewhat similar, but not quite. I mean, we can pretty easily tell somebody that's grown up from or grown up in Newfoundland, typically, or Cape Breton, for example, or the Miramichi even. I've got relatives in the Miramichi, they speak a lot differently than I do. And so you do have regional variations in bird songs. So, so this BirdNet software, not only does it analyze it, but it keeps it and stores it. And it'll store it with a GPS location, so they'll know that, okay, that's a black-capped chickadee from New Brunswick. I'm gonna keep that in my archive. The next time somebody sends something in, I'll have a better reference for it. So it's a pretty cool thing to have. Pretty cool app.
Is there an iPhone equivalent?
I don't know. I don't have an iPhone anymore. I'm sure it is. I'm sure there is an iPhone equivalent for it. I'm sure it's the same thing, just available on both systems.
Cool.
Yeah.
Cool.
Olive-sided flycatcher. Now, this is something, and my screen gets covered up by your faces, but I think the habitat down the bottom says forested wetlands. And for the kids from Elsipogtog, I bet you if you went down on your soccer field, you would probably have a pretty good chance, especially in the springtime, of hearing this bird that likes to live in forested wetlands. So spruce fir forest, maybe a little bit of red maple growing in there, but really spongy and wet underneath. That's where this bird can be found most of the time. Now, identifying this by ear is pretty darn easy. And I'm gonna show you I'm gonna give you the sound. Okay, you got that? Fairly distinctive. Now, I'm gonna give you the PG version of the mnemonic for this, all right? Root beer, okay? Quick, 3 beers. Quick, 3 beers. That one you'll probably remember easily, I'm sure. Remember that it is root beer. That's all I'm saying. All right, so olive-sided flycatcher, quick, 3 beers. So he's a pretty good one to remember. We won't do him. Common yellow throat. Common yellow throat. This is a very topical bird right now because we're in its season, and you'll find out what I mean in just a second. We'll do the mnemonic here in just a second. Common yellow throat. This is the male, of course, with that black band on there. Pretty easy to recognize if you see it, but even easier to recognize when you hear it. I'll show you why. So that is, this one is, let's bring the mnemonic up. Witchity, 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 witch. Common yellowthroat, okay? So again, it's kind of one of these seasonal things. It would be nice to say that you can hear it around Halloween time. No, it's usually spring, singing in the spring. And that song is quite distinctive. Witchity, 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 witch. So an easy one to remember. And if you look down the description, and again, it's covered up here, but it says easily, I put to easily pished. I don't know if you, and you got to be careful how you pronounce this when you're around people. It's pishing, okay? And so you're going to learn how to pish today. What I would like you to do is to, how many people have cats? I reluctantly have 2. Yeah, good dogs. I'm a proud dog owner. I'm a reluctant cat owner. Anyway, when you call your cat, how do you call it? Yeah, exactly. Like that, right? All right, or open up a can of tuna or whatever. But that's one way. So pishing works almost exactly the same way. And I'm going to try to do this, and I don't know if I have the video on, but it's essentially the same sound. Okay, everybody get that? Want to try it? There you go. Yeah, that works. That works. Now, it's not a coincidence that your cat comes to the same call that we're using to pish birds. Because what do cats love to do? Eat
Drink
birds. Drink milk, eat birds. Yeah.
Litter box.
Go to the litter box. Yeah.
Cat do.
That too. All right. We're a little off topic. But they're trying to, when a cat hears you pishing for it, or what it's hearing is a bird in distress. And that's why it's coming to you. Now, after a while, it's going to put two and two together and it's going to say, okay, yeah, that's the person that feeds me. Okay, I'm going to come. But initially, that's why they come to you, because they think that it's a bird in distress. And that's exactly what that pishing sound is to other birds. It's a distress call, and it's warning other birds that, oh, there's something going on here. We're being attacked. Okay. Now, why are we talking about pishing? Because in the wintertime, it's not something you want to do in the springtime, because you don't want to draw birds off the nest. But in the late summer and in the fall and in the winter, for overwintering birds like chickadees, they come very easily to this pishing sound. They're just so darn curious. They have to see. And so if you want to get a good look at a bird in the wintertime, and you know that they're flitting around somewhere, but you just can't get a good look at them, then you pish them. And pishing them by doing the it will actually draw them down fairly closely. And if you're in the Irving Nature Park in St. John, they'll come and land right on top of your head. That's another story for another day. So common yellow throat. Witchetty, 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 witch. That's the mnemonic for that one. Ovenbird. Well, if you take a look at the nest of the ovenbird, you can understand where it gets its name from. Okay, an ovenbird builds its nest on the ground, and it's got this, it's basically an arch. It creates this arched or this domed roof over the nest to provide it protection from, well, from the weather, but also a little bit of camouflage too, obviously, to keep the eggs from being seen from overhead. Now, ovenbirds are everywhere in the forest. And so I wouldn't be surprised if you've heard this one before. Let's listen to it. Now, this one is a favorite of educators. What's the mnemonic for an ovenbird? Oh, let's do this one again. Oh, no. What is the mnemonic for an ovenbird? There you go. Teacher, 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 teach. Teacher, 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 teach. Usually the mnemonic I use. So, hope you guys are remembering some of these things, because there might be a quiz at the end. I'm not sure. Ovenbird, that's easy. You don't have time for you. Okay. So this is by far, between this and the wood thrush, its cousin the wood thrush, are by far the most beautiful sounding birds in the woods of New Brunswick. At least that's what I think anyway. And you can find these in mixed wood stands, conifer stands, typically any of the mixed wood or softwood stands that are near the edges of bogs or clearings. That's where they tend to hang out. But it's the sound of this bird that will stick in your brain. And again, it's something, especially at dawn or dusk, is when you hear these guys most. Let's play the sound. You hear the echo? You hear the echo and the kind of the flute-like sound of that? I'm talking over top of it, which didn't help. But did you hear the echo on that one and all the different sounds? That's one bird. So I got a pop quiz for you. Where would you find, what is a larynx and where would you find it?
On the throat.
It's in the throat. Yeah. It's just down below the tongue, right? Now, what does the larynx do? What's another name for the larynx? Voice box? Voice box is another name for it. Okay, so in a human, the larynx is as you said, it's in the throat, just down below the tongue. The cool thing about the voice box is that, it basically it's capturing air from down in the throat and the lung coming up from the lungs and squeezing the throat at that particular spot over a membrane and making the sounds that way. We have one larynx. We've got one voice box in our body. Not so with birds. Most birds have at least two voice boxes, or one voice box, but a whole bunch of different muscles that are able to produce at least 2 or 3 or sometimes 6 different sounds at the same time. It's just incredible. And this voice box that they have is called the syrinx. And I'm going to try to, here it is here. So I'm going to play the wood thrush. This is a cousin. See, this is where your larynx is here, just down below the tongue. Their voice box, it's called the syrinx, is down, way down, just where the 2 windpipes, the bronchi, break off and go into each lung. So basically, they can sing 2 or more songs because they've got these voice boxes coming off of each lung. And let's just listen to the cousin, the wood thrush. Isn't that wild? One bird's making that sound, and you see on the sonogram on the picture, you can see what side, the pink side is obviously taking the higher notes, and then and that's coming from one side of the syrinx. The other side, or the other notes, are coming from the opposite side. That's how you can get really complex bird sounds. I can't carry 2 birds. I can't carry 1 song, let alone 2 or 3. But they can do that. They can sing 2 or 3 songs. They can harmonize with themselves. I mean, what would the Beatles do if they were in comparison to birds? They couldn't do very well. Harmonize very, very well. I gotta my references because Beatles are probably a little passé. All right, now this is another one. I'm gonna show you some images, and I'm going to provide you with a sound, and you're going to try to guess what it is. I think some of you may already know, but if you do, let's keep it to ourselves for just a bit. But that's my knife, my pocket knife there. So we're talking about a track that's probably about 4 centimeters long, maybe 4.5 centimeters long, in the snow, one in front of the other. I'm going to play the sound. Now you're going to have to listen carefully on the sound because it's not really all that loud. Ready? What the heck was that? You need that one again? You want me to play it again? I'll play it one more time. Try a little guessing game here. Oh, I guess we aren't going to play it. All right. I think a lot of you already know what that was anyway. If you spend any time out in the outdoors, you've heard one of these things. This is, well, most people call them partridge around here. Ruffed grouse is the official name for it. This is a ruffed grouse, and that is the sound. It's not a vocalization. It's not coming from their throat. It's coming from basically, I'll explain it very simply. Basically, taking wind pressure, air pressure, and beating it against their chest. So taking their wings and kind of beating them against the chest. And that's the sound that you hear in the springtime, for the most part, and into early summer. And typically it's done by a male, and he pop up onto something called a drumming log. And a drumming log is, usually it's a hollow log that he's found in the forest. He'll get up on top of that and do that sound. And because he's on a hollow log, it's something like like your acoustic guitar with a hole in it, right? It allows the sound to be amplified. And because of that, it travels further, and you can advertise to a broader range of females that are out there. Okay, so this is, try not to skip ahead too much. Males and females, ruffed grouse or partridge, really the only way you can easily tell them apart is if you look at the tail, the banding on the tail. If it's got a break in the band, as it does on this gray phase partridge, then you're looking at a female, okay? If it was a solid band all the way along, it's a male partridge. Now, partridge aren't migratory. They stick around New Brunswick all seasons, and they are very, more often than not, they are walking on the ground. They do tend to walk on the ground and try to get food off of the ground, berries and seeds and so on from there. And in the wintertime, this is a fairly big bird. It's the size of a small chicken. And when it's walking on the ground or walking on the snow, in the wintertime, it can have a little bit of difficulty, or it would normally, but it has an adaptation as well. It's adapted to the colder climates and to the climate, ones that have snow by this. Okay, you can see the feet, and you see the little tiny basically little nodules on the side of the toes. And in the wintertime, those little nodules actually swell up, and it makes their feet larger. In much the same way as a bobcat or a lynx has big furry paws that allows them to float better on the snow in the winter. These guys, their feet expand out and create seasonal snowshoes, I guess. So, Pam, I'm not sure what we've got for time here. Are we coming
You're doing great, Kelly. It's 22, and I believe class lets out at 2:50.
Okay. All right. So let's stop this guy from calling. Now, I mentioned before about birding by ear, and I mentioned about the projects that we've got in northern Maine and in northern New Brunswick and ones down southern New Brunswick, using those boxes to collect sound. We don't have them everywhere, of course, but yes, we do, don't we? I mean, if we're carrying around phones with us, we've got a way to do something similar to try to identify birds. Sometimes when our foresters are out in the woods, sometimes they come across things that they can't explain very well. Sometimes they'll hear birds. They don't know what they are.
Excuse me for interrupting. Caleb Dawn, could you please come to the office? Caleb Dawn, thank you.
Sometimes they'll hear things. They'll hear birds, but because the forest canopy, the branches are so close together, so dense, it's not easy to see what the bird is or where it's sitting or anything along that line. But more importantly, it's for us, we want to make sure that we're not destroying nests. And so when they hear a bird and they don't know what it is, my instruction to them is pull out your phone, just do a simple video. And I don't even care what the quality of the picture looks like, as long as you've got the audio playing, and send me that short little video clip. And then I can use my birding by ear skills to figure out what that bird is, okay? Because sometimes they will find a nest, they'll hear a bird, and it'll squawk and it'll fly off, and then they'll find a nest, but they don't know what that bird is. And we've got different size buffers that we put on different birds depending on the species of the bird. But if they captured the sound by video, then we can say, okay, well, I know that that's a broad-winged hawk, or I know that that's a red-tailed hawk, something along that line. So this is something that was sent to me a couple of months ago by one of our foresters in St. George district, so in southwestern New Brunswick, and she was in the woods and she heard something strange, and here it is. Sounds like a barnyard, doesn't it? Sounds like a bunch of chickens clucking away. So that's what she heard. Couldn't quite figure it out. She walked around a little bit trying to figure out where the sound was coming from and what was making it. She found some clues, okay? And this is one of them down by her feet there, okay? So there's some bits of fish left on the ground. Oops. And then she started looking around. She found some eggshells, fairly large eggshells, but the size of a goose egg. So whatever bird is in the area, it's obviously a fairly large one. And then eventually, and you can't see it very well, and she couldn't see it very well, but there it is up in the right-hand corner. You can see just barely a nest at the very top of the tree. And so it's important to be able to recognize birds by sound, because you're not always going to be able to see them very well in the forest. These ones is that. It's a great blue heron.
Oh, for Pete's
And
sake.
great blue herons are, well, I think everybody here has probably seen a great blue heron in the marsh somewhere, up along the Northumberland Strait, any of those marshes along the shores up towards Bushbuck, any of those backwater areas have got great blue herons in them. The wingspan, if Pam was to spread her arms out fully, it would be about the same wingspan as that great blue heron. You're talking probably 5 to 6 feet wingspan. So it's a fairly large bird, stands, 2.5, 3 feet tall. Take a look at the back end of the bird. What don't you see on this bird?
Long tail.
There's no tail. There is no tail. And for that reason, they're not great flyers. They're not great. What they will do, though, most birds, when they start flying, they take their legs and they crunch them up underneath their bodies and sort of tuck them in amongst the feathers. And that makes them a little bit more aerodynamic. And it also keeps them warm, too. This one, what they do is they take their feet and they put them way back and act as a bit of a tail and a rudder, almost like you'd have on an airplane. So they use their big feet to help them to steer around. But they're still not very good flyers, and they still have a hard time even taking off. They're just a big gangly bird. So because of that, a lot of the times these birds, you will find them not nesting underneath the canopy, underneath the trees, in the bush or brush underneath. You'll see them essentially building their nests on the tops of trees. And they are what are called colonial nesters. And that means that sometimes you will find 2, 3, even 4 nests in a tree. And there could be up to 50 or 60 or more nests in one spot in an area where there's a bunch of trees clustered. You will find all these birds in that one area. So they're gregarious. They're colony nesters. They nest in a colony, and they nest on the top of the trees just because they have a hard time flying around underneath them. So they just find it easier just to drop in and drop out from the top. So that's a little bit about the great blue heron. So one other thing that I wanted to mention to you about is a project that's kind of near and dear to me. I've been doing this since the start of the Nocturnal Owl Survey, and that's been, it's just been 20 years. Yeah, probably at least 20 years. This is a project whereby you help out Bird Studies Canada, and you help out, the Department of Natural Resources by identifying owls in your area. And you do this by actually going out at night, and they provide you with a CD of owl sounds, and you can pop the
Abby Cormier, come to the office, please. Abby Cormier.
Nope. There we go. You can pop the CD in the CD player of your vehicle if you've got one that's that old. And what you do is you use this playback CD to try to draw the birds to you so you can count them. You're not going to get hundreds of them coming up to you, that's for sure. In fact, you may not even know you get one coming up to you. Birds, owls especially, they've got very, very fine feathers along the leading edge of their wing. And because of that, when they're flying at night, you can barely hear them flying. You can barely hear the wing beat. They're very, very silent flyers. And that's why they do so well at hunting at night. They're silent flyers. They've got great hearing, and they've got great night vision. And so that's what makes them so good at night hunting. And that's their niche, right? That's how they earn their living. They don't compete with the birds that are feeding during the day on the rodents, redback vole and meadow voles and shrews and so on. They hunt them at night. So it's just a little promotional here. It's something, if you're interested in doing it, it's kind of fun. It's especially fun when you get swooped. So you can imagine if you have a CD player on the top of your vehicle or your parents' vehicle, and the birds come in, they do get a little bit agitated and they will come down. And the first time you won't hear them, but you'll see a big shadow go right over top of your head, and pretty exciting. You don't usually torment them too much, but to get one or two little swoops isn't too bad. And usually what they'll do is they will land on a nearby branch, and then they'll call back to you. And that's how you're going to be able to recognize them. There's a training CD that comes with it. You learn a dozen different owl calls before you go out, and then you'll be able to say, okay, that is a great horned owl, or that's a saw-whet owl, or in this case, this is a barred owl. And I don't know if I've got it. Oh, I do have a sound right here. Okay. I'm gonna have to move your picture over here so I can get that here. Exactly. So imagine bringing in a pair of these owls, and they're both coming down at you, swooping you. It's fun. It's unnerving the first time, but it's kind of exciting, and it's all aiding in science, because there's no better way to do a count of owls than getting out at nighttime and doing a survey like this. So if you're interested in something like that, you can probably get your teacher to get hold of Pam, and I can put you in contact with people. Like I said, there are owl routes throughout Atlantic Canada that aren't filled, and they're just waiting for people to go out and to do a survey. My kids have been doing it for 20 some years. They love it. So anyway, so that's about it I have for now. I'm wondering if you guys have any questions about anything. Oh, the mnemonic for that one, and I think Pam, I think somebody was saying it. It's probably Pam. Yeah. So the mnemonic for that one, or the sort of the memory jogger that you can use for that one, is who cooks for you who cooks for you all. All right. So that's the barred owl. That owl is probably 30 to 40 centimeters tall. Not a small bird. Great horned owl, which would probably be about 60 to 70 centimeters tall, a little bit bigger. But this barred owl is one of the most it's one of the most prevalent ones in New Brunswick. Barred owls, most numerous. Great horned owls, second most numerous. Saw-whet owl, which is an owl that's probably about, might be 15 centimeters tall, full adult size, just a tiny, tiny little owl. They're third place in terms of abundance. And a saw-whet owl, when it's calling, it sounds like the backup, like a backup on a truck. Beep, 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 beep. Right? So that's the song. That's the song of the saw-whet owl. So, any questions from anybody on anything?
Maybe not a question from me, but I'd like to share a bird story with you.
Oh, great.
Here is, I don't know if you'll see it. That's back in my university days. A couple of loggers brought me a totally baby crow, and I was able to raise it and feed it. Well, I learned how to feed it, and it became like a dog that flew around the house.
Yeah.
And I have just one more to share with you.
Yeah.
There's my aunt feeding it on the old Chevy.
Yeah, yeah. It's got you well trained, Ivan. You and your aunt both.
That's my aunt with 1970s haircut.
Yes, sir. Ivan, I've got a crow story for you. Crows, and this isn't news to anybody, I'm sure. The corvid family, which includes crows, ravens, and jays, are in our part of the world, they're probably the most intelligent birds you will ever see. And just to explain how intelligent they are, this is I learned this through, and I didn't see it firsthand. I learned this through a course that I took at University of Oregon, and it's about crows that were coming to an area, very intelligent crows, and eventually the university students started to do some experiments with them. And one of the experiments was they would put a mealworm, a dead mealworm, in a test tube, in about a 10 to 15 centimeter deep test tube, and they would fill the test tube with water. And then this mealworm was dead and dry enough, or dead and wet enough that it didn't float. It stayed on the bottom. Okay. So it filled or I shouldn't say it filled. They put water in the test tube with the mealworm, and beside the test worm, they put a pile of little stones. So the birds, these crows would come down, they would look at that mealworm, and they'd peck away at the glass for a little bit. And then they had the smarts enough to be able to take a stone from that pile and dump it into the test tube.
Wow.
And lo and behold, the water level comes up, the mealworm comes up, and then they would dump another, and then they would dump another. They were figuring this out, and this was not over days or weeks or months. This is over the course of hours. They figured this out, you know. So crows are just the most intelligent creatures we've got out there. Very, very smart. They are one of the few birds that we have that actually uses tools. It will take sticks, whereas a pileated woodpecker will use its tongue to grab insects from inside a tree. Well, a crow will take a piece of timothy grass or a small stick. He'll shove it in that hole that the woodpecker's already made, and just wait till he feels a little vibration, pulls the stick out, and he's got a meal. So very, very intelligent birds, and it's really worthwhile to take time to listen to them and to enjoy them. They are truly a blessing to have around us. So anyway, so thank you for inviting me, for letting me share all these cool, wonderful stories. Thank you, Ivan, for that. Always good to see those connections being made, between man and nature. We are one, so there's no reason why we shouldn't. And like I said, obviously they've trained you well because you were feeding it.
Yeah.
Any questions on anything?
I think Kelly, they're welcome to stick around. Some are being dismissed, I'm seeing on the chat, so I've just welcomed people to dismiss, no problem, as they need to. Yeah, you give a whole new definition to bird course.
Yes.
I'm signing up for your bird course. I had a string of questions too, and I think maybe we can squeeze them in Monday, or I can put them out in emails for the kids, and I'll do that. I've taken lots of notes, and I can tell they were engaged as you were talking. We're down to a few left. If there are any questions, feel free. Rachel's gone. Micheline has a few kids left in her class. And the rest, I believe, are...
Yeah, I thought I had them only till 2:45 or so. That's...
yeah, you had till 2:50, I think.
2:50, yep.
Yeah, so...
Okay.
I will stop recording.